Yeah, definitely.
In case, but
So you will go first. If they are not here, we will
start with me. And then, yeah, we'll get some extra time. Yeah.
They are online. Okay. Good morning, sirs, ladies and gentlemen. I would like to welcome you for the second day of the annual conference. And today, during the day, we will touch three topics, three panels. First of all, we'll touch the climate change challenges and security implication. Later on, afternoon, we'll go to air pollution and health. And we'll finish with informatics, remote sensing, high performance computing, and also geographical information system. So for the first panel, I would like to introduce our moderator, Mr. Steve Reka, who came to us from the Pacific Disaster Center. Steve, you can say a few words as an introduction, and we can start the panel.
Very good. Thank you, Colonel.
Thank you very much.
Welcome everyone for day two of the conference. It's good to be back in person after the last 2 years of very challenging times. It's a pleasure to see some familiar faces today, and I welcome those that are online and coming in via WebEx. So a couple of brief thoughts here as we start the panel. Now, first, the title of the panel I think is particularly important because really what we're after here is the implications of climate change. So the title itself is Climate Change and Security Implications. So as we think about the science involved, the research necessary to fully understand climate change, what it comes down to then is how we apply that, how we make sense of that in a security context, particularly for our individual nations, organizations, but also for NATO as an alliance. So today's panel is a very distinguished one. I'm very pleased to be able to join the stage with several of colleagues from around both around NATO, but around the climate change understanding nexus. So first, let me just briefly mention that the other panel members who will be joining here in the short amount of time we have. First, we have Associate Professor Alexander Petrovsky. He's online now? Good, very good. Alexander, I look forward to hearing your presentation. You will lead off after I give some brief remarks. And then we also have Professor Dr. Yavor Chapanov. So very good to see you on. I hope we can have you online here shortly. I will follow, and then we'll have two additional panel members, Ms. Kristina Mateva, if I'm pronouncing that correctly, and again, please do correct me if I miss, and then Dr. Georgi Belov. So for all the panel members, again, look forward to hearing your presentations. It's a good start to day two, and excited to hear about this. So with that, if I may turn it over to Associate Professor Petrovsky, if you have the floor, sir, please.
Good morning, everyone. First of all, thank you very much for opportunity to be a second time here as a part of this annual conference supported by NATO. Thank you very much to the organized committee, and I want to hello every participants here at this year, and I hope so that the next year we will have a chance, all of us, to be on one place and to share meetings and to make our network more powerful in the way of knowledge and helping of supporting the science. My name is Alexander Petrovsky. I'm Lieutenant Colonel. I'm working as Associate Professor at Military Academy, General Mikhail Apostolsky in Skopje. And I'm part of the Military Science and Skills, Professor of Geographical Science. I will start my first presentation for today. As the moderator says, our first presentation is the climate change challenges and security application on the national security in North Macedonia. This scientific paper is working together with my colleagues from Military Academy, full Professor Andrei Liev, Associate Professor Nena Tanesky, and BCC Nikola Spasov. He is a younger supporter here in Military Academy, and I hope so that one day he will be a professor here. The purpose of this research paper is to understand the impact on climate changes on the future security environment, disruptions of citizen safety, forms of disruptions of national security and security environment, as well as the necessary measures and activities for prevention and timely prevention of threats, risks, and challenges of this kind. The paper will also consider the impact of the human factor on the national environment and general safety through its activities and actions on it. As we know, the climate changes is indeed a threat to the national security of nations, and global warming is a multiplier of threats of instabilities in some regions of the world, and such instabilities threatens to affect stable regions given the tensions caused by the climate change. Developing countries, many of which are strategically located around the world, are the least able to adapt and are likely to experience political instability in the face of the extreme weather. Oh, next slide. Okay, introduction part. National security has no predefined content, and we cannot accurately measure the danger that threatens the population and the state. Whether the danger comes from inside or from the outside, and today in the 21st century, we are witnessing new security challenges, in which certainly include climate change and their impact on security. Nutrition systems, economies, settlements, and societies are adapted to the climate in which we are currently living. But what if the climate changes goes too fast and we cannot follow the steps? That the questions that whole world need to think about how to solve it. Climate changes characterize the overall history of human society and consistently forced man and his activities to adapt to these climate changes. During the whole development of humanity, the devastating forces of nature and the repair of the consequences of natural disasters pose a huge challenge, as victims and material losses in these cases are always huge. What about the security policies climate changes now in the world? Security is a complex concept. In all communications, national security is what dominates. large scale of violent conflict is a concern that receives the most attention from policymakers, and the development of the military capabilities to respond to its consumers the most national resources, but alternative security threats such as environmental change are increasingly being considered. Climate change is a security problem from some countries, cultures, and societies through its effects on ecosystems and their populations, and through its indirect effects on development and political stability. The European Union and the world in general are focusing on upgrading security policy and better identifying the long-term challenges of its strategic interests. Worldwide average, almost 3% of GDP is spent on defense, according to the UNDP. Security and climate change are linked, and that connection has led to the agenda called climate security. This concept can be defined as a variety of foreign policy actions aimed at addressing the strategic and political consequences on climate change. The preliminary results are stark. About 70% of nations on the world explicitly state that the climate change is a national security concern. Almost all nations that have official military planning have stated that their government considers missions like humanitarian assistance and disaster relief as a critical responsibilities of their armed forces. As we can see on this figure, this is about the level of concerns about how climate changes threatens the security, and we can see on the map that countries that are in red, climate is not defined as a concern of their policymaker, but I think that something that is happening in Africa has a big impact in Europe, in Asia, and so on. We, as a European country, we affected that most when was the migration problem, and we see that the people who doesn't have opportunity to live in their countries from different reasons, they are trying to came and to live in another country, and that is a problem. North Macedonia is a national concept of security and defense as potential and real risk and dangers that can link to crisis and conflicts, has recognized that degradation and destruction of the environment is one of the causes of climate change, while the Ministry of Environment and Physical Planning of North Macedonia has adopted a national climate change plan, which is guiding document for policymakers in the North Macedonia in creating strategies for reducing greenhouse gas emissions and adapting to climate change, and should strengthen dialogue, cooperation, and exchange of information between all relevant factors in the country, including the governmental, non-governmental, scientific, and private sector, which shows that North Macedonia has taken the climate change seriously on its policy and strategies. The most important climate factors for determining the climate in North Macedonia are geographical position, relief, proximity of the surrounding seas, atmospheric currents, and more recently, human activities. The influence of these climate factors on the territory of our country enabled the presence of the four climate types: altered Mediterranean, temperate continental, and mountainous. This is according to the Assembly of the Republic of Macedonia National Concept for Security in 2003. For this scientific paper, we made two different ways of researching. One way was we make a survey where we have 2008 answering people who are from different age, from different educational status, and different work, and we made some questions how they think that the climate change will affect on the security of the national security in North Macedonia. And another survey that we used some statistical data from Hydrometeorological Institute and pairing these two ways of researching, we did this paper. Regarding whether climate change is a threat to the national security of the Republic of Macedonia, according to the results obtained from the survey conducted for the needs of this paper, in this PI1, does climate change is a threat to national security? 128 of our surveying said that the 62% are knowing that the climate changes will affect the North Macedonia, but 38%, 113 of them think that the climate changes is not a threat to the national security, and that is a scale that shows us that we need to work on public opinion and on educational systems here about the climate changes. Global warming is contributing to increased rainfall as warm air can absorb more water. For each heating of 0.5 Celsius, the atmospheric water vapor increased by 3 and 4%. Satellite observation over the past 20 years, combined with studies of climate models, have confirmed that such increases are occurring worldwide. That means that this is a worldwide problem. As the Earth warms, the atmosphere will be able to absorb more water, and with more water in the air, the trend of increasing heavy rainfall will continue. We take the period from 2008 to 2020 to see the how average perception in millimeters in the North Macedonian Arts, and we can conduct that in the mountain there is a melting of snow and rising river levels earlier in the spring, leading to water shortage in the summer and autumn period, but also floods in winter and early spring. At the same time, due to the rising temperature, winter rains are more rain than snow, which also leads to more floods as a result of combination of rain and melting snow at the same time. That means that the floods will be something that will occur our country and will affect of the national security. In this table, we use the data from different regions in Macedonia, from mountains regions to the, let's say, valleys regions. As you can see, we use it Skopje as a capital town, Berovo, which is mountain region in Macedonia, and we take the average rainy, snowy, and foggy days from the period from 2008 to 2020, and we can see that we have an increase in the days during the year which are followed by rain and snow, and in contrast we have in some places a decrease in the days that were followed by fog. The frequency and intensity of floods in the last few years in North Macedonia are increasing. According to the statistic, the floods were caused by the outflow of the large rivers Vardar, Crna Reka, Strumica, Pčinja, Lepenec, and Bregalnica. And in the period of 1989 to 2006, 44% of all disasters were floods or flooded-related occurrence. On the next slide, we take it the total emissions of polluting substances in the air in the Republic of North Macedonia from 2000 to 2021, and we can see that the pollution is one of the biggest disruptions of human health. There is almost no organ in the human body that is not suffer from the consequences of the pollutions, but the lungs and the cardiovascular systems are more affected, and the most vulnerable category of people are children up to 5 years, the elderly, and the chronically ill, and people with asthma. This means that the working on the air quality is the next step that we need to find the solutions in the way of producing electricity to be from ecological, let's say, producing electricity from suns, from winds, and so on, not from any other resource. Which consequences of climate changes most reflect of the national security of the Republic of Macedonia? Our responders says that the droughts has 28%, the floods has 16%, the forest fires has 16% the same, but the air pollutions was one of the most affected things, and people are thinking that the air pollution will be a problem that need to be solved for the next few decades. Can climate changes cause social division and crisis in the Republic of North Macedonia? We have 50% of our responders which says that it can change the social dangers because lack of food, lack of water will be a problem for every society. 24% said they think that they will know the effect, and 26% doesn't know nothing about the climate change and social dangers. And this is one impact that we need to work in the future decades, I think the most in the educational system. We know that the water supplies is one of the biggest and basic challenges of our time. By the middle of this country, over 30% of the global population will be living under increased stress from water scarcity. As the population grows, tensions between different water needs will increase. On this map, we can see the countries in red that have a high lack of water. We are still in a part of low lack of water, southern part of southeastern part of Europe, but water stress can be a problem in the next few decades because as we know, especially my country, most of the water is using for agriculture purpose, for irrigation of our agricultural areas, for food production, for both humans and livestock. And that's mean that if we don't have a water, we will have a problem in agriculture because without food and without water for drink, that is a huge problem for national security. In this table, we have the projected changes in the air temperature for Republic of North Macedonia from 2025 to 2050 and 2100 in the 4 seasons, winter, spring, summer, and autumn. And we have 2% of all our basics needs is water for drinking. And if we know that we have 713 kilometers squares, that means that we have 488 kilometer quadrats of water surface. That is, I think, small amount of water. And the analysis of Republic of North Macedonia says that the reserves of water in Macedonia will be a next problem. This means the rivers will have a low level for 20% in next 20 years. That is a big percent in losing of water. And for that climate scenarios, Republic of North Macedonia is using the models of the Intergovernmental Panel on Climate Change, namely A1B to B1 MAS, whose characteristics describe the current level and the future technological, demographic, economic, and sociological development of Macedonia. Based on the modeling results, the following can be concluded: that it's likely that there will be a steady increase in temperature between 2025 to 2100. Compared to the period between 1961 and 1919, the projected changes from the period between 2025 and 2100 will be the most intense in the warmest period of the year. It is possible for average monthly temperature during the transition between winter and spring to equalize this period. For the period between 2025 and 2100, a decrease in perception in forecast in all season and annually, and the largest decrease will be during the summer. As we know, the last year we will have a big forest fire near to Bulgarian border, our NATO ally in Berovo, and that was one problem that we cannot solve alone, and we needed to have international help. And when we talk about the forest fires, we know that the fires doesn't know about the borders and so on, and that means that we need to cooperate more on this scale. The intensity of changes is greatness in the warmest part of the year, in July and August, and they may be no perception at all. In the cold period of the year, a decrease of perception is up to 40%. That means that we will have a problem with the water and floods in the spring. According from this table, we can see that it's likely that in period 2025 to 2100 will be a continuous decrease in the amount of the perceptions. The forecasted changes will be the most intense in the one part of the year. So this means in the summer. So the summers will be drier, and it's likely that some summer months, July and August, will be without perceptions, and that will be a problem for our country. And at the end, which sector will be most affected by the climate change? Our responder says that environment and the national security will be most affected in the climate changes for the national security in our country, and other 2% will be affected in the water supply, in agricultural, economy, energy system, public health, 34%. And according to this, I can say that this means that the climate changes will have a serious impact on national security in North Macedonia. And this means that with national strategy plan and as a part of NATO and a country who is candidate to be a part of European Union, we think that cooperating on different level, institutional level, and making some, let's say, projects, European projects and cross-border projects will help to solve this issue on national and regional plan. Thank you for your attention, and I hope so that will be some questions for me at the end of this session.
Very good. Yeah, very, very good. Thank you. If I'm off mute here for the online audience, thank you very much, Colonel. Very, very much appreciate your presentation. Some excellent points on climate change as a driver for security threats. You outlined that very clearly for how we think about it in a very practical way at a national level. We're looking at weather events such as flooding, more rainfall, faster snowmelt, and the implications that has for food security across the board, the environmental health aspects of it, all very essential. I look forward to having the question and answer period with you at the end of our panel discussion. Again, Alexander, thank you very much for an excellent lead-off presentation for today. I think based on who else is online that I've been asked to go next to give my presentation. So if we can call my slides up, please. So while the slides are being brought up onto the screen, again, very, very briefly, what I wanted to talk about was that nexus again between the good research that many of us are doing, but apply that in a way that we can think about it in security actions. And so this presentation will be fairly short, but I'd like to talk specifically about how to translate the science and the research into an applied product. So next slide, please. So NATO as an alliance is also a warfighting organization. How we think about the implications of changes in climate, I think, are essential for it. We talk a bit about climate security, and we're just now starting to get a better understanding, I think, as defense and security forces, what that means. And I've broken this out into 3 different categories. There are points on the slide, you can read those. But the categories that I identify and I work with as I understand climate security is, first, it's the impact on defense and security infrastructure. The military bases we have, if we have seaports where our naval forces are they impacted by sea level rise? How do we think about that? How do we adjust our infrastructure? Our air bases, again, looking at weather-related events. Perhaps they're in flood zones, flood plains, more wind, et cetera. Our military bases around. So how that defense infrastructure is impacted. The second part is it's the roles we also have now. As Alexander mentioned, we're expecting our defense and security forces to do more in humanitarian assistance and relief operations because of changes in climate. We're starting to see additional impacts again from flooding. So search and rescue operations, bringing relief supplies in. So that impact again on our roles. If we're doing more search and rescue and we're doing more relief operations, that means we're not doing more training, more operations for potential combat related missions. And then third impact area is on civilian populations and the drivers of instability. Again, Alexander, you mentioned that very clearly. Some of the challenge that the Republic of North Macedonia is facing, how your surveys show that there is concern over the impacts on the civilian population. But think about, again, the alliance and how our individual nations will respond to migration issues, perhaps political instability as we look for resources, water, food resources, et cetera. So those 3 areas, first, on defense infrastructure, second, on the roles and missions of our defense and security forces, and 3, on drivers of instability that will also change how we think about the potential for warfighting. Next slide, please. And the next slide. Thank you. Perfect. So as the Colonel mentioned at the outset and leading off today's discussion, I work with the Pacific Disaster Center. And many of you, again, are familiar with both Pacific Disaster Center and the work that we do there. But let me just give a brief background on it. So PDC, or the Pacific Disaster Center, is actually a global organization. It's based in Hawaii. I keep trying to get this conference moved from Sophia to Hawaii, but I've had little success so far. But Sophia is beautiful, so I certainly can't complain. And so the work we do generally is, again, translating that the science and much of what we're heard yesterday, and we'll hear again today and some tomorrow on climate, translating that into a way that we can apply it to military operations and how we do our planning as well as our response. Pacific Disaster Center, I mentioned, it's part of the University of Hawaii, based on the island of Hawaii, but we have representatives around the world. I'm based in the state of Colorado in the United States, and work primarily with NATO, Europe, but also Africa. So enough of background there. The approach we're taking here is to understand climate risk and how we think about where we will put our resources as we understand that risk. So if we focus on that last impact that I mentioned, so defense infrastructure is one, roles emissions 2, and then drivers of instability is 3. Climate risk is, and that driver of instability is really the focus of how we might think about down to the indicator level of where we might make a difference in this. So climate risk in our methodology is comprised of 4 different areas. First, understanding exposure, and I'll talk about each of these briefly separately. Understanding vulnerabilities, this is population vulnerability and the drivers of that vulnerability. And third is coping capacity, so those government mechanisms that will help us cope better with climate change. And then fourth, and something new, we're trying to understand how we can apply the research into a practical application is climate engagement. How much effort is a nation, is a community making towards achieving, working towards the UN and Sendai framework for climate change goals, how we look at disaster risk reduction in terms of practical application through government action. Next slide, please. So let me talk a little bit about climate exposure. This is what we generally think about when we think about climate change and the risks associated is, will we have higher intensity hurricanes, tropical cyclones, storms, et cetera? What are the impacts on flooding, wildfire, drought, sea level rise, extreme precipitation, extreme heat, then leading to, again, think of some of the other implications from these, and the number of consecutive dry days. These are the ways we start to think about how a population is exposed to both currently and in the future, right? And the notion of understanding this over time helps us understand how not just weather changes, but the climate changes will drive our planning process for defense and security. So again, climate exposure, the first element, and understanding climate risk. Next slide, please. And just 2 brief examples that I pulled from some recent research we've done in the Bahamas, the islands off the, in the northern part of the Caribbean. So first, trying to understand, in this case, this first slide, wildfire hazard exposure. So again, Alexander talked about the concerns in North Macedonia regarding increased number of wildfires and intensity. That's in the Balkans, and seriously a serious concern for the region as we look at these hotter, drier summers, lower precipitation levels. We look at wildfire issues, but then how we think about the propensity of wildfires and how the population and infrastructure are impacted. So looking at models to help us understand, okay, we know this is an area where we're likely to have wildfire exposure. So what's in that area we're concerned about? Is there defense infrastructure there? So my first impact. What part of the population and what's significant population infrastructure? Again, think hospitals, think schools, public health facilities, et cetera, would be impacted. Next slide, please. This next slide shows, again, for sea level rise, the areas impacted in the Bahamas. While the area is not so relevant for us in this discussion, the Bahamas, but think about this in your countries and in our region, the areas where we might deploy forces, how we start to understand how the population and the infrastructure be impacted. Again, so defense infrastructure, how is that impacted? How might we think about we need to do more relief missions there because a greater part of the population will be impacted by it. Good. Next slide, please. The second component of understanding climate risk is vulnerability. And again, this is the conditions in society that might be drivers to lower resilience by the population. So next slide. And there are 3 slides here, and I won't describe them in detail, but just please, if you have a chance, take a look at the indicators. So again, as we try to understand what makes a population vulnerable, we try to drive to the most significant and lowest level of understanding as possible. Why? Because that's where we'll likely make the impact, right? So if we understand that the marginalization of the population, that's the 4th black circle there. What drives marginalization? Is there There are issues with gender inequality. And again, one of the major NATO obligations now is looking at women, peace, and security. That is the WPS there under gender inequality. How do we think about managing that? What resources, what training do we provide? Are there things that we can do in each of these indicator levels on the far right-hand side that will make a difference? Next slide, please. More sample indicators. As we go to slide number 2 here, looking at population pressures, not a surprise, especially as we think of if we have fewer resources because of climate change, right? Because of increased heat, more rainfall, more flooding, drought, that's going to drive more change when you have a highly populated area. More likely it'll have migration, and again, the impacts to us and neighboring states or regionally. And next and last slide here. Again, some additional, some economic drivers. And then the second one here, the recent disaster impacts. As we think of population's vulnerability and its ability to respond and recover from an incident, whether it's this season's flooding, this season's wildfires, is if we've just come off a bad season, the previous year, my personal resilience is going to be lower. I'm likely to be more vulnerable to it. So thinking about how we increase during the interim, during those the months where we're still recovering from the last disaster, how do we prepare for the next round? Next slide, please. The next area is coping capacity. And again, this is the means and systems, the processes a government uses to help that population cope with and build resilience. Next slide. And similar to the other areas, coping capacity has its own set of indicators from governance, economic capacity, how the food system is managed, processed, and how resilient is that. The water system, which is, as we appreciate, is a significant driver of insecurity in a community. And then the capacity of infrastructure, which breaks down further into healthcare, communications, and transportation. So we look at each of these levels, and we get data in each of these indicator levels to help us understand the larger picture of where we go with climate risk and where we can put our resources. Next slide, please. Climate engagement's the last category. And again, as I mentioned, this is how a government is applying, or a community is applying its resources to try to meet climate change objectives. So how we think about mitigating climate change. Next slide. And we're under consideration here. That means this is a new category of research that we're trying to make useful for adapting to policy and defense planning, and looking at some of the indicators that might help us understand how a community is actually engaging with and working with climate change in its community. Okay, that summarizes essentially what I want to talk about. Last slide, please. My contact information is here. I'd be glad to talk more about this. This is an effort that combines some of the previous research that we've explained through the conferences before, as we look at how we provide analysis that supports defense planning. If you have questions, please reach out during the session here, during the Q&A. As the moderator, I won't question myself, so you get to ask those questions for me. But I look forward to the discussion at the end here, and if you have questions, my contact information as well is at the bottom of the slide. I look forward to following up. Thank you very much, and I look forward to our next presenter here. So if I may, is Professor Dr. Shapunov online? No, not yet. Christina, are you with us yet? You are. You're present. Oh, very good. Okay. Is this Lilia? Good, Lilia. Thank you. Welcome. Please join me here in the center. Thank you, Lilia. Thank you. Welcome. Welcome, and we look very much forward to your presentation, which addresses assessment of contemporary climate change in Bulgaria using the Köppen-Geiger climate classification. Thank you very much. While we're waiting for the slides to come up, and they're just coming now, here we go.
Okay.
Very good.
Okay. So I'm Lilia Borcheva from National Institute of Meteorology and Hydrology in Bulgaria, and I will present our research with Christina Malcheva, which is the main collaborator here. Assessment of contemporary climate change in Bulgaria using the Köppen-Geiger climate classification. Next slide.
Yeah, next slide, please.
So the recent climate studies expected unprecedented climate change to the end of 21st century, and under the worst case scenarios of anthropogenic forcing of climate system. And the territory of Bulgaria belongs to the temperate climate zones of Europe, which is experienced fast warming in recent decades and expected ongoing warming in the future climate. There is many climate change indicators, but the climate classification-based approaches receive increasing attention because of their capability to identify the spatial temporal patterns of the potential biodiversity changes across the world. So the most widely used is Köppen-Geiger climate classification, which is from the end of 19th century, so we use it nowadays very wide. Climate classification turned on the efficient diagnostic tools to evaluate spatial and temporal climate transitions under the changing climate. And our study aims to establish not only the shift between the two reference periods, 1961-1990 and 1991-2020, but also to extend the tendency of changes at different time scale using the observational data and Köppen-Geiger classification criteria. Wow, it's too fast. The Köppen-Geiger climate classification is based on the idea that local vegetation best expresses the climate of the area, and therefore the boundaries of climate zones are chosen taking into account the distribution of water, and they combine average annual and monthly temperatures and precipitation as well as their seasonality. So it's a Köppen-Geiger classification for Europe. Bulgaria is in the temperate zone. There is a short description of this classification. The first level, it's a dependent criterion in 2 or 3 letter code. The first level criteria define the 5 major climate types. A, tropical, B, arid or dry, C, temperate, D, boreal, continental, it depends on the, and E, polar one. And the different thresholds, temperature and connected was obtained to define the boundaries of these different climate types. The second level criteria account for the precipitation regime and their variability, especially for climate of temperate and boreal type. The second letter indicates whether there is a dry season. For F, for climates without dry season, CF and DF, S for dry summer, and W for dry winter. And the third level criteria account for the thermal regime for climates mostly B, C, and D. It's arid, temperate, and boreal. And here is the simple scheme of this classification, different types and combination of this. So the data we used is from 108 meteorological station, which is relatively evenly distributed on the territory of the country. And they're from the National Institute of Meteorology and Hydrology, and for the 6 years period. And before we use them, they go through the primary expert control. The monthly and annual climate normals for the precipitation and air temperature for this station are calculated with, we use the data with at least 80% density and continuity of time series, and all normals for true reference period were calculated according to the World Meteorological Organization requirements using the specialized procedures in SQL environment. Then all calculation and scripts were made in free software environment and we use for maps freely available QGIS. The missing monthly values were inputted using the R package MIS MDA by applying an iterative principal component analysis imputation technique, which considers the internal structure of the data and the links between individual time series. The calculated monthly and yearly temperatures and precipitation normals for tourism reference period were interpolated on the regular 30 arcsecond grid, and the special interpolation method used in this is regression kriging. The altitude and its derivatives of grid points were obtained from the digital terrain model of the Japanese Aerospace Exploration Agency using the freely available QGIS. And then the R packages are used for regression analysis and spatial modeling. And the grid points were processed under the Köppen-Geiger classification scheme using the own developed R script. It was developed by Kristina Malcheva. Additionally, sliding centered windows with a time step of 1, 11, and 31 years was applied on the calculated annual cycle of precipitation and average air temperature from all stations to obtain the respective sliding Köppen-Geiger classification during the low period of observation. And there is two charts which present two different periods. First one, 1961 and 1990, and 1991, 2020. On the right, you can see the difference between spatial distribution of different types, climate types, and the changes. Here, three major climate types are distinguished in both periods: temperate, which can be without dry season, with hot or warm summer; Mediterranean type with dry and hot or warm summer; boreal, it's in mountainous regions without dry season, with warm or cool summer; and polar alpine tundra. And you can see here. Well,
Here we go.
Yes. So the difference between these two maps you can see on the next slide. Here is the transition between different types. They're bolded in different colors. Difference in Köppen-Geiger climate classification between reference periods consist mainly L1 transition to different climate types, E to D, D to C. So it's polar to boreal, boreal to temperate. L2 transition is to drier subtypes, CFCS, and L3 transition to warmer subtypes. Transition to cooler, wetter subtypes are colored in blue, but it's very few places. L3 transition from warm to hot summer in the temperate climate have the greater contribution to the climate shift, more than 30%. The share of L2 transition is 1.7%, and compromising shift from the temperate humid subtypes to the drier subtypes. But also the opposite shift from dry to more humid climates exist here, but it's a very few percent. Further analysis of transition from different types and subtypes, mostly in southern and southwestern mountainous areas, is required to distinguish real shift from the interpolation uncertainty. The other L1 transition consists of shifts from boreal to temperate climate, which is about 2%, and from alpine to boreal, which is 0.5% subtypes. But the actual area reduction for these types of climates is huge. It's about 17% of one of them, and for alpine to boreal, it's about 69%, so which is a huge percent for this. In relative to the previous 30 years period. And now the dynamic of long-term shift of is presented here. It's a long-term variation of the temperate climate subtypes obtaining base station data in the central 31 years sliding window. The climate types and subtypes for a given location may shift from one to another at different time scales, and there the stability decreases towards shorter time scales. The evolution of the main climate subtypes is calculated by station data for 31-year and 11-year time scales. The script applying the sliding window technique to the Köppen-Geiger classification scheme generates time series of calculated Köppen subtypes for each station attributed to the central years of the sliding window. The computed frequency of individual subtypes for each center year by all stations is divided by the number of stations to obtain the relative frequency of the Köppen subtypes, and here the dominant subtypes CFA and CFB turn out to be the most variable ones on opposite direction in the middle of in the beginning of 80s. It changed their values in our climate, which results in a small total change in the climate, but different subtypes of them. The alpine climates presented by three of the highest mountainous peaks here, and show that there is a stable transition to boreal climate at the 11 years time scale for peak of Chernibruk, which is the lowest one of these since the beginning of 21st century begins. And while the in this 11 years sliding window, obviously we can see the decadal transition between climate subtypes, which confer the long-term reduction of boreal climates, and the cooling in the beginning of 17th also revealed the cycling of Mediterranean and steppe climates. You can see little waves of yellow and brown here, which is repeated all the time. And here is presented the year-to-year variation of the Köppen-Geiger subtypes or annual climate types are used in classification approaches counting for both average climate types and interannual climate variability. We found 13K climate types, which corresponded to the significant climate diversity in Bulgaria. And here is well pronounced the years with, how to say, with more boreal climate subtypes is dominant with we have very cold winters, like is you can see it in years with blue mostly. I don't know where is the point here, how to use it. Never mind. So you can see also that 2000 is a drought year. It's this brown in this year. It's reflected in BSK subtypes. The general tendency in the low period is expressed by the reduction of cold subtypes and expansion of temperate subtypes, and the natural precipitation seasonality is represented by balanced proportion of W and S subtypes. And to conclusion, generally 7 Köppen-Geiger subtypes characterize the climate in Bulgaria. The shift from colder to warmer or drier climates have affected much larger areas than changes towards the cooler and wetter climate. Alpine climate indicates the most considerable percentage change, while the absolute terms temperate climate show the largest increase. The dominating subtypes CFA and CFB turn out to be the most variable ones during the 31 years time scale, but in opposite direction, which results in a small total change. A decadal transition between climate subtypes confirmed the long-term reduction of boreal climates and the cooling in the 17, but also revealing cyclicity of the Mediterranean subtypes. And the interannual variability of Köppen-Geiger subtypes correspond to the significant climate diversity of Bulgaria and confirm the general tendency to the reduction of cold subtypes and expansion of temperate subtypes during the 16 years period of interest. And thank you for your attention. It's a photo from our station. Stars the goal.
Thank you, Dr. Lilia. Thank you very much for the presentation. The essence of understanding climate change impacts is an accurate evaluation of the data, and letting the data drive our understanding. And so Dr. Bolcheva did a very fine job helping us walking through the understanding of the Köppen-Geiger model and using data again graphically to help us see the impacts of climate here in Bulgaria, climate change in Bulgaria. Very comprehensive study, research. Congratulations on that. That 60-year period I think is essential to helping us understand that the two different 30-year periods really captures the changes in climate. And many of us, when we get to the question and answer period, will still wrestle with understanding how climate change impacts our security decision making. But by the research and graphically depicting is very helpful for then us applying the science behind it. So with that, may I ask do we have any other panel members that are online? Is Georgi online? He is. Yeah, so Dr. Belev, if you're online, may you join us? Ah, very good, very good. So Dr. Belev will talk about climate change implications on the condition of road surface in Bulgaria. So Georgi, your turn, sir.
Не тук скрин. Не се чува. Ето така, сега тук вече шер. Къде ни е шер? Не трябва да имам презентация. Мисля, ние сме не, ще трябва да шерваме. Ще трябва да шерваме нашите. А ние ли сме наред? Can we start our presentation?
We can see your screen.
Can you see our screen?
Yes, we can. Can you hear us?
So can you start?
Виждаме ви екрана.
Can we start, please?
Please go ahead.
Yeah, okay. So we would like to present our about the climate change implications of the conditions of road surface in Bulgaria. We work about the freezing of surface layer of road surfaces because this is a dangerous meteorological phenomenon that can cause serious traffic accidents, which are accompanied by serious damages, injuries, and even death. There are studies investigating the factors for road freezing and the role of different agents. For example, there are recent studies in 2020 that analyzed the scenario for road freezing sections by applying the evaluation algorithm that derived the road freezing of the change of the road surface condition and water film thickness of the freezing sections. The urgency of the problem is related to the investigation of the relationships and patterns between dangerous and unfavorable processes and climatic features in Bulgaria. We are freezing.
Заби компютър.
We have a technical problems with the moving.
Не знам. Дали ли сме я? Дай нашата презентация. Ето е. Това не е нашата презентация, но е забила.
We cannot move the presentation, so it's...
Не може да продължим презентацията, заби.
Georgi and Petya, if you stop your screen sharing there, we will share the screen from here.
Връзка share screen.
Не ги чувам.
Не виждаме нищо.
Okay. Okay, actually we moved. Yeah, sorry for
Oh,
that.
good. We can see the
So
second slide now. Good.
I'll do it a little bit faster. So the country is located in the southeastern part of the Europe and is characterized for the complex mosaic relief, which suggests the certain peculiarities and manifestation of specific climate elements. The main focus of the study is the freezing and also mainly in the spring and autumn period, which actually is the more interesting for us because normally in the winter season, the drivers, the vehicles are better equipped, and also the driver, their behavior is more careful in comparison of the spring and the autumn period. This is the one interesting event, which is the black ice, which is represent a thin transparent ice cover on the asphalt, which is invisible to the drivers, and that's why it's so dangerous. The genesis formation of black ice is associated with certain meteorological conditions in combination with the influence of the terrain. The main factors are the temperature, which is passes around 0 degrees, a little bit less, a little bit more than 0 degrees. And so in the spring of the year, it is also supported by the advective frost, which is predominantly related to the invasion of cold air. While in the autumn, this is a radiation frost predominate, and the genesis is related to the radiative cooling of the Earth's surface in clear and quiet weather. The target data we also relate is based on the Copernicus climate change database for the period of 3 years, and we proceed with the net CDF files in the geoinformation environment raster, which is generated of the temperature transition through 0, 1, and 2 degrees Celsius, and the situation of real freezing are presented through the risk models marked as emergencies, which is known as a red alert 1, red alert 2. Several types of ice can be formed of the road surface. Just in brief, this is a columnar and pure or black ice and white ice. We are interested in the following indicators for analysis. This is the number of days of freezing, which is the annual sum of the days, with the minimum temperature, which is the minimum temperature is below 0. The number of days of icing, the annual sum of days with the maximum daily temperature below 0, and the extreme values of the minimum temperature for a certain period. The monthly minimum values of the average day temperature, and the percentage of days with the minimum temperature. Here is the map which shows it is a hypsometric map which shows is superimposed with the road layer, which represents the situation of the country with the roads and the hypsometry, which we would like to talk about. And it was already mentioned that Bulgaria is located in the southeastern part of the continent, and the complex dissected relief determined as now climatic factors, which is it have a significant impact of the condition for freezing of the road surface. This relief. The most important for the studies process is the winter season with the greatest frequency of the days which transited in 0 temperature. The start and the end dates of the first autumn and last spring frost is essential for this freezing, for the analysis and understanding of this freezing process. We are not considering the highest mountain areas in the country, which is peaks Musala, Vikrin, Botev, and the attention is focused on the certain areas which have a specific physical and geographical question, which is the high valley fields, such as Sofia, which is about 550 meters above sea level, Pernik, 700 meters above Dupnica, and Samakov, which is almost 1,000 meters above sea level. Many of the given above sample territories are characterized by the location of large cities, economic activities, and related height waves with a heavy traffic during the seasons of the year. especially this which we are talking about. We are at the latest. The last situation is occurred in June in the high parts of Western Rhodopis and some high values of Western Balkans such as Draguman, Breznik, Trân, Ihtiman. Several maps has been created for the purposes of our research and for the periods of 2017 for the autumn-winter period, 2017, 2018, 2018, 19, 2019, 20. And these maps, which we will see now in a minute, they are presenting the visualization function, and figures 2, 3, and 4 have analytical functions. Here are the maps for the first year, 17, 18, where we can see the risk of freezing. Freezing it's actually in a red color, and where the red color is representing the higher risk. These are the risks during the next period, 18, 19, and we can see also the slight changes actually, which is the increase of temperature. Actually decrease a little bit the risk, and this is the situation in the next period, 1920. We of course do not consider the red color, which is representing the Black Sea, because this is just technical understanding of the understanding of the machine. So actually, this red color is not considering the red color in the map. As a conclusion, we actually the potential for road frost is decreasing, but the danger of extreme temperature during the transition periods, October, November, and March, April remain. And the invasion of cold weather masses from the northeast to their collision with the warm, humid air in the Mediterranean cyclones from the southeast is able to create a favorable environment for freezing roads, especially when soaking cold air masses from the Arctic or Siberia is establishing the anticyclone lasting several days. And based on this analysis, several highly vulnerable regions can be identified in the region of Bulgaria with a certain extreme weather event, which create really high risk of freezing the roads for the dangerous conditions for the drivers. The most risky regions are the high valley of Western Bulgaria and the northern part of Western Rhodope, and the Danube lowlands with the Dobruja Coast and the Bulgar lowland. Here, the last map with these regions with the different risk possibilities for risks, and actually the upper Thracian lowland is defined as a medium degree of risk, such as a Black Sea coast, and the southeastern part of the country, which is Stranja-Sakar. The high-risk areas fall into the temperature continent climate regions, the Danube part, Pred-Balkan, and the Danube lowlands of the Dobruja Plateau. Actually, the prevention, there are certain measures for the prevention of the road frost, which are offered some conditions, which are the sanding accompanied by the use of salt, which in turn, when it's dissolved in water during the thawing process there. But so the control which remains essential on the road traffic and the personal responsibility of drivers. But this knowledge is really important in order to increase attention for these areas which are with a high risk of frost. Thank you for your attention.
Very good. Thank you for your presentation. So, Petya, thank you. The excellent comments on the dangers of black ice, the concerns we have, but most importantly, how we map those dangerous areas and visualize it so that we can respond and prepare successfully for it. I look forward to have some questions on that, since I live in a mountainous area of Colorado, and I'm familiar with with the dangers of driving in black ice or not being able to see it in the first place. So I very much appreciate that. I look forward to our discussion. I think, as I understand it, that Dr. Chalpanov has not been able to join. I know he presents later today, so maybe he will have his merge his presentations in the afternoon session. So with that in mind, I'd like to open up our question and answer period now. I have a series of questions, but I'd rather first look to our in-person audience to see if there are any questions, and then our remote audience, those that are online, to see if there are any questions, and then I will fill in any blanks. We have a bit of time since Dr. Chalpanov did not join us, so that's more room for discussion, which is arguably the best part of these sessions. So any questions from the audience here at the facility?
Yes, I have.
Online we have, Fisto.
Actually, I want to make a statement. This is not a question. The last presentation with authors Belev and Radovanova is not original. The original idea for this subject is from Dr. Vladimir Ivanov from the Geophysical Institute, and the bigger part of this presentation was made during Copernicus Data Store training course in February previous year. The showed results, partly the composed new NetCDF files are mines. And actually, Radovanova and Belev has stolen our results. That's all. It have to be very, very seriously considered before any publication. I'm expecting explanation and excuse from the both. This is it. Thank you.
Thank you for your comment, Risto. Dr. Belev, Petya, would you care to respond? Do you have any questions or follow-on comments to that?
We had the problems with the hearing. We didn't hear very well the question. Is it possible to write it down in a chat and then we can answer?
Ще ви го повторя на ясен български език. Оригиналната идея не е ваша, на доктор Владимир Иванов от Института по геофизика, география и геодезия. Една част от резултатите, които представиха, отново не са ваши, а са начертани от мен, които ги предоставих по електронна почта на Георги Белев. Вие просто сте ги откраднали и изобщо не цитирате нашето авторство.
Excuse me, sorry for interruption. Sorry for interruption. The language of the conference is English language, so please speak English. Speak English, not your native language. Thank you.
Dear Chairman.
This excellent comments. I think this maybe it'd be best if we take this into the chat feature in WebEx, if we are able to do that. That way that Risto, you would have the opportunity to explain in more detail your comments to Georgi and Petya. That might make the most sense, I think, for the time we have available here. With that, may I ask, are there other questions? Lilia, please. Good, good. Alexander, can you hear? This question is now for you.
It's very low voice and I can hear nothing.
Thank you, Lilia. Again, Alexander, this question is for you. So, Professor Petrovsky.
Do you hear me?
I know, I'm hearing.
Okay. Okay, I have a question about your presentation because in first part you present a rising precipitation sums during the last 15 years in Macedonia in different points. And then in the end of the presentation, the future climate for Macedonia, you expect a reducing of precipitation all the time. And the first year is 2025, which is so close.
Yeah.
How can you explain, because the trend you present from the previous 15 years is a rising precipitation and maybe
The table 4 was connected with table 3, where we see that according from the table 3, the air temperature in Republic of Macedonia will increase, and we'll have a periods. We'll have a periods where the air temperature will go very high and the precipitation will be very slow, and the periods where the precipitation will be high, but the effects of the precipitation will not be in the use of let's say the agriculture.
I expect that. Sorry, I expect that the climate is not so different in Bulgaria and in Macedonia. So,
Yes, North Macedonia.
North Macedonia. Okay.
Maybe the
And
near borders places have the similar climate, but
we have the same. The temperature rise higher and higher each year, but the precipitation regime is not so. How to say, in Bulgaria, the precipitation annual sums is without any differences during the last 30 years period, I suppose. But there is inter-annual change in precipitation. But climate modeling show that in a rising temperature, we expect a drier climate here. But maybe for our area, it's not so fast. Will happen.
yes, because
maybe I suppose it's
you have the Black
the
Sea.
same will be in Macedonia.
Yes, you have the Black Sea and more water, but we are a mountainous country, and we don't have, let's say, sea and big waters around us, and the highest mountains is affecting of the percent of the rains here in Macedonia, and in the last year we have more stormy weather, stormy rains and so on, not let's say calm rains and so on.
Okay.
Thank you. Thank you, Alexander, for your response. There,
Thank you very much for the question.
Alexander, since you're close to being online, if I may ask another question here while you're there.
Yes.
You talked about the planning requirements around with your survey results as well. Did you have any assessment on the role of security forces? Any recommendations based on your survey results, or were they merely, and again, very comprehensively, but were they mostly just the survey results capturing an understanding versus recommendations? Did you have any recommendations from them?
Yes, from the survey records, as you say, the effect that the climate changes have of the national security forces are the lack of time of training. And another issue is that we need to prepare our, let's say, soldiers to be more effective in those moments of, let's say, floods, forest fires, and so on. And as we know, the main use of the army forces is not just in the war. That means that we need to engage more forces on the ground when something happened here, or to give forces for conducting missions in our neighbors. Let's say in 2014, as I remember, our forces were in Serbia, conducting the problem with the floods. And last this year, we have NATO forces that were here. That means that climate changes have a serious impact of the army security forces, and we need to invest more in equipment. We're dealing with some crisis situation that happen from the climate changes, and we need to invest more in the training of security forces in the way to dealing more faster and more effectively in the prevention or in the preparation time.
Very good. Very good. Thank you, Alexander. Thank you very much. Dr. Bocheva, so Lilia, may I ask you a question next, and that would require you to come back to a microphone. Thank you. As you looked at the variation, please, as you looked at the variations over the two 30-year periods, you captured the trends to a more temperate environment here in Bulgaria. Do you see anything to indicate that that trend would change or discontinue in the next decade or 30-year period if you were to conduct a study again 30 years from now?
What concerns the temperature, the trend is upward all the time. So maybe we expect more warmer climate, but what concerns the precipitation, which is also in this indicator, there is not a real change annual, perennial. Maybe we expect 20 years ago, we expect that we will have the reducing of the precipitation regime here. But it's not happened because the annual precipitation zones are almost the same or above this 30 years ago.
Yes, very good.
So,
okay. Good. Thank you. May I ask you to stay here?
Okay.
Are there other questions from the audience here at the location? Are there additional questions from the online audience, those on WebEx? I have one more. Colonel, if I may ask one more question to all the panel members that were able to present. Part of the title of the presentation, our panel was on the security implications. So for Georgi and Petya, and also for you, Lilia, Alexander, and the security implications. So in the mapping for the black ice, Georgi and Petya, for the climate, the understanding through the Köppen-Geiger model, how we're thinking about climate change. Did we map those against defense or security infrastructure in the country? Is that something that was maybe either part of the existing research or something to consider for future research? And how that might impact our infrastructure here in Bulgaria, and then also in North Macedonia. So may I turn that over if there are any comments? It may not be part of the research, but I thought I'd ask that as we closed out this session. Any panel member have a thought on that? Good. I guess that answers my question then. That's easy. Well, thank you very much for an excellent panel. Thank you for your time and wonderful presentations. Very informative, very useful. If I may now shift to a break here at this location. So I think we're talking about 1 minute. So we have 1 minute comments here from Colonel Jersey, please. Thank you, Lily. Thank you very much for joining.
Sirs, ladies and gentlemen, I just have few technical issues. Please, during the presentation and during your comments, use the proper naming of the countries. Another one is we already experienced. I would like to remind you again that the language of this conference is the English language, and the native language, it's not allowed here during this conference. And last issue is real-life support. Would like to remind you that the icebreaker will take part today at 17:30 in the Astoria Hotel. Thanks very much.
15-minute break. So thank you everyone again. We'll take a break now. So a 15-minute break, that brings us to, boy, this is a higher math for me. That brings us to 10 minutes before the hour, I believe. So close to, let's start at 10 minutes to the hour. So at 10:50, please. Well, good morning again, everyone. Welcome back after a brief break. It's good to see again so many people that are able to join us in person, and for those that are online on WebEx, again, welcome back to our session. So as we continue this panel discussion on climate change and security implications, we have some additional researchers and presentations that I'm very excited about. I look forward to hearing these. The first up now after the break is Dr. Hristo Chervenkov. Hristo, I know you were online earlier. If you are ready to go, sir, we are ready for your presentation.
Thank you, Mr. Chairman.
Perfect.
I will share my screen.
And for those that are joining, Hristo's presentation will be on the applicability of the CHIRPS precipitation product in the regional climatology of Southeast Europe. Hristo, it looks like you were trying to share your screen.
Yes.
There we go. It's beginning now. Very good. And we can see your slide number 2, your outline.
Yes, but not in slideshow mode. Maybe. Oh, no. Excuse me. Yes,
Are you able to expand your slides?
Oh, yes. I can start.
If you're able to put the slides in presentation mode, we are ready for you. If not, then we can manage the slides from this end.
Could you start my presentation, please? Do you hear me?
We do, and we're working on it on this end. Thank you, Hristo. Can you see your screen and the slides showing up on your screen, Hristo?
Join meeting. Dimitrov. Yes, thank you. Thank you for, excuse me for the delay. The title of my presentation is Application of the CHIPS Precipitation Product in the Regional Climatology of Southeast Europe.
Dr. Cherenkov, can you stop the YouTube channel on your computer? We're getting an echo with your voice.
Do you hear me?
We hear you, but there is an echo.
Yes.
Do you have the YouTube channel on? Are you watching on your computer as well from the YouTube channel? If you could quit that, please.
Do you hear me clearly?
Христо пуснал два акаунта. От два компютъра може би, не знам. И за това става ехо.
Не го чувам. Аз си казвам. What I should do? I go further. Could you show me the next slide? No, the previous. This is the outline of the presentation. First 3 days motivation for the consideration of the CHIPS precipitation product, goals of the study. Second, short description of the CHIPS, the observed data set and the EOPS which is used as a reference, the used methodology. The core of our presentation is in point 4, the performed calculations and the obtained results. And 5, the summary and the conclusions. And finally, the acknowledgement, of course. The next slide, please. Next. Yes, thank you. As you know, the precipitation is key component of the global water cycle. It's essential climate variable. A key importance of wide range of climatological applications. Analysis of climate variability and trends require long-term, temporally consistent and reliable precipitation time series, as possible homogeneous also. Consistent and accurate precipitation estimates are also relevant for importance for regions like our region, Southeast Europe. Е хубаво, чувам, че е лошо качеството. Какво да направя? Where agricultural crop production is the main.
Okay. So Risto, we're going to take a break here just briefly to work the technical issues, only because of the echo coming from your screen. So thank you for your patience with us as we work through the technical challenges. Risto, I will get back to you, or one of us will contact you here as we resolve those. If I may, can I ask if Dr. Popov is Risto, you're available? So let's try that. Dr. Popov is here with us in the audience here at the location. So we'll go on to presentation number 2 now, and Dr. Cherenkov we will work on the technical challenges, and we'll bring you up as soon as we're available to do so. So Risto, thank you for joining us here. So as Dr. Popov joins us here, his topic, as you can see on the agenda, is heat waves over the Balkans, a statistical analysis, possible causes, and physical drivers. Lisa, welcome. Yeah, it's a pleasure.
Thank you.
Yeah.
Nice to meet you.
Over to you, sir, when you're ready. And then we get the slides up for Dr. Popov. Perfect. Thank you.
So thank you for the opportunity to be here and to present my work with my colleague Stepaniuk. Part of our job is heat waves over the Balkans, statistical analysis, possible causes, and physical drivers. And can I use that?
Maybe a little slow.
So, extremely high temperatures are a phenomenon that has a direct impact on human health and especially on the elderly population, as well as those with health problems. At the same time, extremely high temperature have an economic impact by creating conditions for compromising the agriculture harvest. Heat waves are often accompanied by drought, leading to reduced water availability for irrigation and drinking water supplies. River temperatures are often raised during heat waves, which can cause a serious problem for cooling of power station. Also, lower river and lake levels during heat waves can lead to algal blooms, causing mass mortality of fish and birds and posing a serious health threat to both animals and humans. So, better understanding of the physical and dynamical processes governing European heat waves is essential for improved predictability and adaptation measures. Data and methods that we used. So we used ECMWF ERA5 and ERA interim reanalysis, satellite and ground station data. ERA5 provide hourly estimate of a large number of atmospheric, land, and oceanic climate variabilities. The data cover the Earth on a 30-kilometer grid and resolve the atmosphere using 137 levels from the surface to a height of 80 kilometers. Reanalysis datasets are created by assimilating climate observation using the same climate model throughout the entire reanalysis period in order to reduce the effects of modeling change on climate statistics. Reanalysis combined model data with observation from across the world into a globally complete and consistent dataset using the laws of physics. Within current project, we perform statistical analysis of extreme temperature condition over the Balkan Peninsula. Analysis start with determining all extreme heat weather events happened within past decades, starting from 1950, based on a 5-degree criteria. So the World Meteorological Organization defines a heat wave as a 5 or more consecutive days of prolonged heat in which the daily maximum temperature is higher than the average maximum temperature by 5 or more degrees. We aim to find correlation between circulation and extreme weather events. Possible correlation are to be used for training of neural network for creation of a prediction model with our property software, which is currently under development. Project result will help to better understand physics and driving factors of extreme weather phenomena. In this slide, we can see the circulation influence on extreme heat events. The maximum air temperature is slightly affected by the shape of terrain or the surface. In most cases, the absolute maximum values are related to meteorological situation covering significant areas. Usually, the situation in which we register extremely high values of air temperature are associated with anticyclone forming along the Azores maximum or high pressure reached and associated advection of hot air from south and southwest. Since the beginning of the century, the temperature records in Bulgaria in terms of extremely high temperature have been corrected several times. So in this slide, I show some situation in June 2008 and July when extremely high temperature are registered between 36 and 39 degrees Celsius. In outside mountains part of the country. So in this period, the record of the temperature for the Sandansky, which is in the southwest part, is over 40 degrees. In the summer of the same year, several more periods with extremely high temperature above 38 degrees were registered also. This is some situation in July and also in the August. So some of our calculation mapping on this slide. Heat waves occurrence during 1994, 1998, 95, sorry. In the period, some of us remember this hot summer. We call it in Bulgaria also American summer because this is the moment when we have the greatest success in the football in USA World Cup. So, and the next heat waves occurrence was in the period in the summers 1998 and 1999. So the tendency in frequency of hot days show us that the number of the days increased for the last few decades. The graph showed the change in the average number of hot days in the North and South Bulgaria for each year since 1961 till 2019, compared to the reference period 1969, 1961, 1990. In the last 30 years, the upper limit has more than doubled, reaching 36 days above the norm. But the speed, the change in this indicator is relatively reduced. In over of the 19% of the station, there is a statistically significant trend of increasing the number of hot days by an average of about 3.5 days per decade. The year with the highest number of hot days is 2012, when 43 days was a hot day average for the country. The record for this year in North Bulgaria is 73 days. calculated like hot days, and in for South Bulgaria in 96 days in Sandansky. So next work that's we work on that in deep statistical analysis, including precipitation and dynamic meteorology parameters for the period 1915-2022. Improving the concept with direct tracking of the cyclones instead of using oscillation indexes with neural networks. And correlation analysis, we will compare heat wave occurrence with circulation. So part of this work is financed with has been carried out in the framework of the National Science Program, Environmental Protection and Reduction of Risk of Adverse Events and Natural Disaster, approved by resolution of Council of Ministers and supported by the Ministry of Education and Science of Bulgaria. And thank you for attention.
Very good, Lisa. Thank you. Thank you for a good presentation, a good way to lead off this session of our panel. If I may, I'll call you back up when we do the question and answer period at the end. But thank you again for your remarks and leading us off. Talking about heat waves, now I know about the American summer. So how did Bulgaria do in that summer in the World Cup?
We finished on the 4th place in the world. Yeah, I remember it because I was young boy and I was very impressed by that.
Me too. That sounds very good. But I wasn't so young in 1994. Thank you, Risto.
Yes,
thank you very much. If I may ask our technical team, how are we doing with Dr. Chervenkov? Do you think we have those problems resolved, or should we move on to the next speaker? Another speaker. Very good. Okay, thank you. Dr. Ivanov, are you in person or online? Are you available?
Yes, I'm online.
Yes, you are. Thank you. Dr. Ivanov will be speaking on the estimation of historical and future renewable energy potential with RED CM4 over the region of Southeastern Europe.
Yes, good morning. Good morning to everybody. I'm Assistant Professor Vladimir Ivanov from National Institute of Geophysics.
So I'll turn it over to Dr. Ivanov. Is that okay then? Yeah, very good. Thank you.
Yes.
Dr. Ivanov, can you hear us? I see your slides are on the screen.
Yes, I hear you. Yes.
Vladimir, can you hear us, sir?
Yes. Do you hear me? Do you hear me?
Very good. We hear you.
Okay. So I'm going to present you our results from estimation of the historical and future renewable energy potential with RED CM4 over the Southeastern Europe. So wind and solar radiation are sources of renewable energy, which is almost no harmful for the ecosystems. And these technologies are under constant development. And there are already a lot of wind farms and solar power plants are built in many locations of Southeastern Europe, but still there are territories that might be suitable for building these kinds of power plants, and or these wind farms and solar panels could be built in a more effective way. And so for equalizing of those assumptions about economic activity, energy sources, population growth, and other socioeconomic factors, the climate modelers use so-called representative concentration pathways for the projected changes of the concentration of greenhouse and other gases. as a land use till 2100 year from now. So our aim is to assess the current and future energy potential from wind and solar resources by the numerical modeling under these three emission scenarios. It's RCP 2.6, 4.5, and 8.5. And for this purpose, we use two characteristics. For wind power, we use wind power density, which is given here. And the solar power is assessed by the shortwave solar radiation flux. And the differences between the scenarios and between the future scenarios output and historical period are assessed by the error called mean bias. So the Rexium model is a hydrostatic. We use the hydrostatic option of this regional climate model with a horizontal resolution 20 kilometers and 18 vertical levels. Outputs are in 3 hourly intervals, by 3 hours. We use we use two future periods from 2020 years to 2050 year, and for 2069 to 2099 year. And the historical period which we compare the future simulations with is from 1974 to 2004 year. The Rexium 4 is needed by initial and boundary conditions which are taken from the UK Met Office Hadley Center Earth System model. And the physics processes of the model, they could not be simulated directly by the model. So there are several so-called parameterization schemes which are used for that purpose. These schemes are for planetary boundary layer, for large-scale moisture exchange, for convection, and for radiation processes. So these are here are shown some results about the average wind power potential and average of daily maximum of the wind power potential at height 100 meters for the two future periods, near future and far future. The dimensions are in watts per square meter. So these results that show that mean power density is going up to 150 watts per square meter on most regions. There are not distinct patterns of spatial distribution, but there are some features connected with the topography. They are on the Adriatic, Aegean, and southern coasts of Turkey. These are here are shown the mean biases of these two characteristics. So we see that the largest changes are projected for the far future of RCP 8.5 scenario, followed by the RCP 2.6 and RCP 4.5 for the near future. And the results for mean biases of daily maximum wind power projections show these patterns, as you see on the last two figures, last two rows of figures, even more clearly. And the biggest differences are between the far and near future simulations for RCP 8.5 scenario. So let's see some results about the shortwave radiation. Here are shown the average of the daily sum on the radiation fluxes and average of daily maximum shortwave fluxes. So we see that there are some zonal differences in the northern and southern areas, appearing as slightly increasing fluxes from west to east in the northern regions, and from central to west and east in the southern regions. And these patterns are stronger even for daily maximum distributions. So let's see about results about the mean biases. We see that they are positive, with some little exceptions. And the flux we see that the flux is expected to increase more in the northern areas of the domain. And the largest biases are projected for the RCP 8.5 scenarios for the far future, of course. So as a conclusions, we can say that higher wind potential is modeled in the course of the seas, except the Black Sea, and the sign of change depends on the location rather than the topography for now. And the climate projections have biggest positive changes on these regions and far to the north. It's about the shortwave. It's about the wind power potential. As to the shortwave flux biases, they are positive, which mean decreasing of the cloudiness in the future and more favorable condition for energy production from photovoltaic and solar thermal system as a whole. And bigger changes are seen to the north than to the south. And as a future development of our work, we see some possibilities for changing the horizontal resolution and using a model ensemble, varying the dynamical properties in physics and or the initial and boundary conditions by using general circulation models, which could well, in this way we can get eventually better results from for future. I want to thank you for this research for the program of National Science for the environmental protection and reduction of risks of adverse events and natural disasters, and with the financial support from the program part of the national Bulgarian national roadmap. So thank you for your attention.
What's the security implications, let alone implications for most of our energy needs in the future, the notion of assessing the potential for wind and solar, particularly wind in this regard, much of your conclusions leading to good investment decisions as we think about where we would put our limited financial resources to manage our energy needs in the future. So nicely done. Thank you very much, sir, for that presentation. We're going to make one change in the program here. Dr. Yavor Chapanov wasn't able to present this morning. There were some technical difficulties. We will bring him back in. So Yavor, if you are available now, we'll bring your presentation up. So Dr. Chapanov, can you hear me? You'll be up next. Dr. Chapanov, can you hear me, sir? I think we all appreciate that technology is a wonderful thing until it's not. But we will get there. I know Dr. Chapanov is online, so hopefully he'll be able to join us shortly. And I just have a question for a follow-on presentation here. Dr. Bolcheva, Lilia, will you be doing the presentation as well? Were you for this next on, or will that also be Dr. Pofristov? Okay. Okay. Cool. We'll see how that goes next then. We'll see if you're called back to the table here. That's right. Yavor, can you hear us? Coming next. Okay. Well, very good. So we'll continue on into our program here. Mr. Pofristov, we're not sure.
Can you hear me?
Is Mr. Pofristov on?
Yes.
Sorry, yeah, next one. Thank you.
Yes, thank you. To start my presentation?
Very good. Just please, yes.
I will share my screen.
It's showing.
Yes, thank you. Hello, everybody. The topic is the frequency of freestyle cycles across. One moment, please. Just full screen mode. The frequency of freestyle cycles across Balkan Peninsula in the period 1991-2020. I'm working with National Institute of Meteorology and Hydrology, and this work is made along with my colleagues, associated professors, Dr. Hristo Chervenkov and Dr. Lilia Bocheva, associated professors, and Radoslav Evgeniev and Dimitrina Todorova. Something about definition of freestyle cycles. We mean minimum daily temperature below 0 degrees Celsius and maximum daily temperature above this value. Something about mechanism of freestyle cycle, how it works. When water penetrates in some kind of material, and consequently freezes, it enlarges its volume between 7 and 9%, and it causes cracks in the material. After melting this ice, on the next cycle, freezing cycle, water fills this enlarged volume cracks, and on the next cycles, everything repeats again. The effects of freestyle cycles, it affects many spheres of life. For example, here are given few examples. For example, weathering of rocks. One of the main causes for erosion are freestyle cycles. It also affects mining industry, affects surfaces of airport runways, also vehicle road networks. It is cause for making cracks in it. Also, building surfaces can be a cause of soil erosion and soil runoffs. And in the northern zones, it affects permafrosts. About annual distribution of freestyle cycles, more than 100 meteorological stations are examined. And over 100 days yearly have stations situated in concave terrain forms in central Romania, Western Bulgaria, and North Macedonia, on the altitude between 600 and 800 meters above sea level. The lowest values of the peninsula have below 20 days per year, have stations near Adriatic coast. About seasonal distribution, In winter, average for the area, there are 37 days. More than 50 days in the season have stations in southern part of Romania, western part of Bulgaria again, and North Macedonia. Below 18 days in winter season have again stations near Adriatic coast, and also stations on the highest mountain regions above 1,800 meters, because in winter months temperatures are constantly below freezing point for a long time. In spring season, average number of days is about 13 for the area. More than 25 days to 41 have again stations in concave terrain forms in central Romania and western part of Bulgaria, also in North Macedonia, and also several stations in Slovenia. Below 5 days in this season have stations near the coasts, not only Adriatic but Black Sea and Aegean Sea coasts. In summer months, the average value is below 1 day for the season, and only highest only in the mountains it occurs in the summer, and also sometimes in concave forms above mentioned between 600 and 800 meters. In this season, the parameter depends strongly on altitude, and the highest value is over 15 days average for the season have Musala Peak, the highest point of the peninsula. About autumn season, 10 days on average for the peninsula, above 23 to 38 days have again stations in central Romania and western part of Bulgaria and North Macedonia. And below 4 days for the autumn season, they have stations near the coasts, near the coast, because in this season still warm sea waters affect these areas, and days with frosts are little then. Here, concerning all seasons, first two diagrams show that in eastern part of the peninsula, the highest areas in over 2,500 meters have maximums in autumn season. All other stations in the mountains have maximum of freestyle cycles in the spring. Another thing is that on the highest peaks, Musala and Omu in Romania, winter is the season with the lowest values with freestyle cycles. All other stations have maximums in the winter. More about monthly distribution. In January, 58% of examined stations have maximum. In December and February, these percents are 17% of the stations. For example, in December, these stations are situated in northwestern part of Bulgaria, in Serbia, Bosnia and Croatia, and eastern part of Romania. And in February, with maximum in February, are stations in Slovenia, Hungary, and northwestern part of Romania. In March, just 2 stations have maximum. These are Miercurea Ciuc in Romania and Murgash Peak in western part of Balkan Ridge in Bulgaria. In April, it's interesting that maximum in April have maximum in the altitude range between 1,800 and 2,400 meters. These are Bielasnice Peak in Bosnia, Botev Peak, and Chehleau in Romania. Over in highest areas of the peninsula, over 2,500 meters, the maximum is in Mount of Mai. These are Credarița Peak, Musala Peak, and Omu Peak in Romania. Here are given monthly distribution of stations above 2,500 meters. We can see two maximums in the year, one in the autumn and one in the spring season. From distinction here is that from November to March, more cases we can view at Credarița Peak in Slovenia, and this is probably because of its relative proximity to the Adriatic Sea, and warm air Mediterranean masses easily reach these westernmost parts of the peninsula. Interesting here is that Musala have a maximum of all stations in the months from May to September. In this range of the altitudes, we see again two maximums, one in autumn and one in spring. But from November to April, cases decrease with increasing the altitude in this altitude range. Bielasnice Peak in Bosnia have less cases in September and October, maybe due to its relative proximity also to the Adriatic Sea. Here are given stations at the bottom of hollow fields. These are these three stations in Bulgaria, North Macedonia, and Romania. We can see two maximums again, like in the mountains in spring and in autumn. These maximums are occurred also on Trun station, but in southernmost station Berovo, we have only one maximum in the winter. Berovo station in North Macedonia has a maximum of all stations in winter months, in December, January, and February. Mercurea, Ciuc in Romania have maximums in transitional season months, March, April, October, and November. Monthly distribution of stations situated in most populated areas at lowlands below 600 meters are given here. From west to east, we have in western part of peninsula, we have decreasing of the cases. Here in eastern part of peninsula, these are stations in eastern part of the peninsula. We see a little increasing of the cases in all months. Stations near the coasts, we can see that eastern coasts have more cases than western and southern ones. That's because of more easy reaching of cold air masses to these regions not protected from high mountains. About the tendency of annual values of number of days with freestyle cycles, according to performed man-candle text with 5% significance level, we can see that 46% of the examined stations have statistical significant negative trend. These stations are situated in Bulgaria, Romania, northern part of Serbia, and eastern part of Croatia. And just 2% of the stations situated in northern part of the peninsula have positive statistical significant tendency. Here are given absolute minimum, absolute maximum, and average annual number of days with freestyle cycles in above stations. Also is given statistic of man-candle test and estimator of sun slope. Bolded stations are these with statistical significant trend and no matter positive or negative. About conclusions, the highest annual number of over 100 days with freestyle cycles in the Balkans are situated in meteorological stations in hollow fields, both closed hollow fields between 600 and 800 meters above sea level. The lowest annual number of days are registered near the coasts. The parameter rise with the altitude, but above 1,500 meters it starts decreasing. Again, in the highest areas over 2,500 meters, average annual values are increasing again. The parameter depends on several factors. One form of the terrain, proximity of great water basins, altitude, latitude, possibility of advection of cold, warm, or humid air masses, and radiation cooling on every specific location. In 94% of the stations, maximum is in winter. Over 2,500 meters, these areas, highest areas of the peninsula, maximum is occurred in autumn, and in the altitude range 1,800 to 2,400 meters, it appears in spring. About 46% of the stations, the tendency is statistical significant negative on annual basis. Also, something interesting in traditional season, months like October, November, March, April, almost 90% of stations have statistical significant decreasing tendency, but in the mountains, the effect is opposite, and the days with transition to 0 degrees are rising, and the tendency there is statistical significant positive in the examined period. So, thank you for your attention.
Thank you very much for your presentation. I thought, again, interesting, we talked about climate change impacts, is that these freeze-thaw cycles and the impact on infrastructure, civilian infrastructure, but as well as our defense and security infrastructure. So I look forward to some good questions regarding that. But thank you very much for your presentation. And again, another excellent presentation that keeps us right on time. If I may now ask Professor Lupia Pasheva to come to the front stage. Please join. So Professor Pasheva will be talking about preliminary analysis of high frequency sea level data from 2 Balkan tide gauges for the period 2013 to 2020. And this will be our last presentation before we have question and answers, and then we go to lunch. Okay. So very good. Okay, welcome. Yeah, thank you.
Okay, thank you very much. I'll try to keep the time.
And my job is to help you with that. So.
Yeah, okay. So, thank you. Good morning to everyone. I will present a preliminary analysis of high-frequency sea level data from 2 Bulgarian tide gauges, recently updated, I would say, before about 10 years ago. Located in Varna and Burgas. My presentation will be focused only on preliminary statistical analysis of these data. I'm not intend to going in depth to present too much statistical information, just to show some graphs. I will explain what is actually the main purpose of this research. Everybody knows that if you want to rely on the scientific based analysis and evaluation of sea level rise, we have to use very carefully all raw data, very carefully to process preliminary in order to obtain a very reliable assessment for the sea level trend. I will show some results of this very short time series analysis, some recommendations concerning the tide gauge infrastructure available along the Bulgarian coastal line, and some notes about the future maintenance of this data. Probably you know that the sea level is one of the primary indicators of global climate change, so-called essential climate variable among the 54, if I'm not wrong, essential climate variable. Actually, the sea level data is very important because they used not only for the scientific multidisciplinary research, but also for many practical purposes. Actually, we use the data for definition of heat systems all over the world, also for determination of this so-called form of Earth geoid, studying of sea surface topography, also many other scientific parameters. We also use this data to monitor the ocean and the sea circulation in different ocean and sea basins all over the world, also to study different phenomena along the, not only, but primarily on the coastal zone. Sometimes this data from continuous sea level registration by tide gauges are only data used for tsunami events, which actually happened in some places all over the world. This is one note. Actually, in Black Sea basin, there is also several tsunami events in the past, which are happened in more than 2,000 years ago until now. These events are about 30, actually. Sea level data are used also for studying of recent vertical crustal movements along the coastal line, also studying of coastal erosion, sea abrasion, and also very important data for calibration of all satellite altimetry data. Especially if you perform a continuous registration of sea level change, we can actually study the extreme events such as storm surge, also tsunami events, which not too rare happened along the coastal line in the world. What is actually the practical use of this data? They are used for many operational oceanographic purposes, also for preparing of maps for hazard and risk of floods in coastal zone. Actually, Bulgaria now implement the second phase of this European directive for flood risk analysis. Also, these data are used for preparing the tidal tables all over the world and many other practical purposes, especially for establishing infrastructure along the coastal line and port engineering activities. Actually, in the Black Sea region, there are several tide gauge stations. Most of them are not active at the moment. What concerns the Bulgarian coastal line, there is 4 geodetic tide gauges. 2 of them in Varna and Burgas have started to work at the 13, actually in 13 in the past century. Actually, this in Varna works until now, but in Irakli and Burgas is here a pointer. Yeah. It doesn't work. Okay. Actually, this in Irakli in October stopped to work in the past, actually before 10 years ago. What is important is to assure a quality of this data in order to perform any scientific analysis for evaluation of the sea level trends and any extreme events. In this particular case, I use only data for these two tide gauges in Varna and Burgas in this short period, when actually the digital sensors was installed. In first picture, you can see where is located the tide gauge in Varna, in the harbor area. And in the right picture is shown the old equipment. This is a German equipment auto type tide gauge, which actually removed when installed this digital one in 2012. They worked together parallel in 1 year in order to compare the results obtained from digital sensor and this old one, analog apparatus. Actually, the digital sensors are installed in 5 locations in Baltic, Varna, Škorpilov, Tipomori, and Burgas. Actually, some of them at the present not active. There is a consortium between Bulgarian Agency of Geodesy, Cartography, Cadastre and Cartography, and our Institute, National Institute of Geophysics, Geodesy and Geography, and Institute of Oceanology. These 3 institutions actually collaborate in order to maintain the tide gauge stations along the Black Sea. This is the web page of our institute. In this blue line are shown the information which are actually provided in real time. In the red arrow is shown where actually, if you clicked, you can see the results for minute values of some of these tide gauges. On the next picture, you can see the web page of a National Oceanographic Data Center located in the Institute of Oceanology. In the left column with the red arrow is actually shown the sea level network, which our colleague maintained parallel with us. And if you click on this link, you can see the graph for a daily sea level registration. Also, there is, according to the national roadmap for establishing of research infrastructure, there is such kind of research infrastructure, which included also updating of all old tide gauges along the Black Sea coastal line. So, as I mentioned, the most important is to assure the quality assurance and quality control of all raw data. There is a different level of processing of raw data. Actually, what is actually means quality assurance? This is a process which is employed with hardware to support the generation of high quality data of sea level observations. What is the quality control? It involves follow-up steps that support the delivery of high quality data and requires automation and human intervention during the data analysis. Actually, quality control, there is a different software also that can be used for preliminary processing and analysis this data. There is some flags which can be used to show is there quality control is applied, is they applied in real time? Where is the what is the timing? Is there a gap in the observations, etc.? Also, what kind of quality control is applied after the preliminary processing? What in how we can interpolate the missing data, also flags for quality of the data, some questionable data, and some other actually marks and flags for quality of raw data. What is actually we aims to develop and maintenance of metadata for data and instrument hardware, which installed in our tide gauges. Also to perform a quality control using automated and manual procedure, which unfortunately in our case, there is no national acceptable procedure how to perform this quality assurance and quality analysis until now. But hopefully it will be happened in near future. Also, final verification and certification of data quality. So the continuous registration of sea level at tide gauges in both stations in Varna and Burgas, they have many shortcomings. One of them are related with the gaps, which takes from several minutes to several days until to more than years for this very short period, I would say about 10 years. Here is one of example of tabular report, which is actually downloaded on the tide gauge digital recorder in Varna. You can see marked in this red line, there is actually missing data between hours 4 until 2023 at the same day. So there is several procedures accepted in the international level, which recommended when we can interpolate the data or not to interpolate the data. And the second example, you can see this is the tabular report from tide gauge Burgas. Here you can see that every second value is repeated the previous one. There is a probably technical problem. Also, there is several financial problems concerning with maintenance of these digital sensors installed in these both stations. These graphs shows only the minute values for month of October in 4 different years. You can see that there is very specific graphs, especially in the 2014 in October. It's about between 20 and 23 of October. Probably there is storm events. At the moment we analyze this data, comparing them with meteorological information, which actually provided by our National Institute of Meteorology and Hydrology. Also, you can see on the right side in 2016, there is a very expressive graphs. You can see the daily variation, also some probably extreme events happened during the half of the month of October in this year. Also in the bottom, there is a strange graph in October 2019. At the moment, I couldn't say what is actually this graph looks like in this way. Probably additional analysis is needed. These graphs, you can see the sea level for Burgas for the whole year period, 2013, 14, 15. This is only for examples. You can see on the bottom right graph that there is a strange big errors. Probably the sensor doesn't work well, so operator doesn't react at that time and didn't repair this station. Some statistical characteristic of raw data for this 8 years for Varna, you can see that if the sensor works normally, there should be not missing values back, but actually in different years there is several missing values in the both black values are shown. The average missing values in percentage. You can see that during the last years these missing values are increased. On the next slide, you can see these values for the type gauge in Burgas. Unfortunately, this sensor stopped to work in 2018. At the moment, our colleagues from Institute of Oceanology repaired and updated this sensor. You can see that there is many identified problems. Actually, we can say that there is operational staff who maintain these type gauges, lack of enough education and qualification to maintain such specific equipment. Also, at national level, there is no regulation on application adopted in international level for procedure how to operate these type gauges. And also, in some cases, because there is a different institutions in Bulgaria which actually installed several sensors along the Black Sea coastline, most of them doesn't have enough experience, doesn't have enough knowledge how to operate this data. They only put these sensors on the coastal line and they provided data in real time only. But they didn't archive this data for scientific analysis on the, which are actually very important for the preparing a forecast for the future, also for analysis of the future floods in the coastal zone. Also, there is several institutional gaps and deficiency, lack of good coordination between the government, also different stakeholders, including between the scientific organizations in our country. Also, there is actually no good relationship with the business organizations, which could be, and maybe the end users of these scientific products, which is very useful for practical purposes. Also, lack of legislation concerning the different responsibilities of institutions in our country, and a lack of regular approach how to proceed with the collaboration with the international institutions and how to provide data. Future perspectives. So I would say that on the scientific base, we try to overcome all these problems which I mentioned before, and to assure a high quality of the type gauge data in order to perform preliminary analysis of these data, in order to assess sea level trend and to make scientific based forecast for the sea level rise in our region, but not only in our region. So here is some references. Thank you for your attention.
Very good. Good. Thank you very much. Thank you. And so Professor Pachvula, thank you for just sea level rise. When you think of the data you provided, the quality of the data, and you talked about quality assurance and then quality control of that data. Everything we've talked about so far this morning has been around the research, which requires validated data. And I think that your emphasis on that point, that and the other piece I wanted to mention is that having an interactive website from Geophysics Center, very useful to be able to, for other researchers, us on the applied side, pulling the data directly from the website and seeing that real time seems very interesting and useful. And then I think probably new for some of us is thinking about tsunamis in the Black Sea.
Yeah.
Right. I mean, that's probably shouldn't surprise us, but again, something to be considered of. So thank you very much. If you would maybe stay here, and Risto, maybe I could bring you back up for the question and answer period. If you'd come join us at the front, would you be able to come join us, Doctor? Yeah. Thank you. So now we have time for a question and answer period before we break for lunch. So if I may first ask in the audience here, we've had several good presentations already. Are there any questions from those that are present? And any questions from our online community? Anyone on WebEx that has a question? It's quiet. Let me ask one then, if I may, just to start. Again, we're balancing in our presentations here at the conference between the excellent research that's being conducted with the application of that research. So, Risto, if I may start with you, as we think about the research you've done, the applications there for the security and defense communities, what would you say would be the largest implication you've come across for defense and security?
So it's difficult to say what is the most important, because my work have application in many different ways. For agriculture, for example, for health organization, for also for infrastructure also. Today I present just some little part of work with my colleague. Next step would include with precipitation data and analysis. The heat waves are connected also with droughts, and I said that it's connected with the problem with the fresh water. So when we have long periods with heat waves in combination with droughts, in Bulgaria exactly there is problem with the waters, and I show the summers of 1994, and this is the last summer when there is, I remember, the 3 years with a lot of droughts, and in Bulgaria we had a lot of problems with fresh water, especially in the East Bulgaria. So my work, there is a lot of implication in this field. We can talk so much about
probably
that.
Very good. Thank you.
May I ask my colleague, probably if I remember correctly, you mentioned in your presentation that you used Copernicus data, Copernicus services data.
Yes.
Is that correct? Because they provided such kind of forecast also for heat waves or covering whole Europe.
I'm not sure the data is from Copernicus, but we have planned to use also and Copernicus data. For the moment, we used ECMWF data. And we used some models data also. But in the next research, we will use the Copernicus data.
Very good, thank you.
May I add something? Actually, Copernicus services provided very useful information for scientific research, but it's very important to have in mind that in situ data is very important in order to verify the data which actually obtained from the satellite observations in order to perform good analysis and forecast for different extreme events happened over our territory.
Very good. And so just to confirm for the audience, most of us, I think, are maybe familiar with Copernicus, but you mean the European Union satellite cluster that's providing the data. Very good. Thank you. Dr. Ivanov, any comments or follow-up from you before we close out this session? Or Mr. Yeah, please. Or Mr. Popristov?
Yes.
Just ask if you have any follow-up, if there's anything else you would like to add before we close the session.
I didn't understand on which topic.
Good. Yeah, thank you. I'm sorry to make that not so clear. My question for you really is, do you have any final words before we close out this particular part of the panel discussion? Anything you would like to add?
Yes, that about freestyle cycles or about other topics.
Just again, we only have 1 minute left in the session here. If you had any final words on any topic, just to close out the session.
Yes, the previous work of Hristo Popov was interesting, and which includes heat waves. Yes, it was interesting. So
very good. Thank you. I think we're actually doing very well with the in-person and the online. It's a little bit more challenging, I know, for all the context around it. But thank all the panelists. Thank everyone for the contributions for this session. This was a good session to break before lunch. We'll lead into lunch now. We'll return at 13:30, 1:30 p.m. So look forward to an enjoyable lunch, and then we'll see everybody back here at 1:30. Thank you. Thank you both. Thank you both. And thank you online for providing your presentations. Have a good lunch. Thank you.
Thank you.
Thank you. Thank you both. Thanks to your
Test.
people hear me?
We look forward to it. Thank you. Welcome back, everyone that's online, and welcome back to our significant crowd here in the auditorium. Thank you all for the session this morning, the presentations we've had already. This afternoon, we'll finish off the panel discussions with Walter David. So welcome back. It's great pleasure to see you here again at the event. We don't have any further introductory remarks, but I look forward to your presentation, and I look forward to the question and answer session after.
Yes.
Over to you, sir.
Thank you very much. This research comes from a collaboration between Ronin Institute that I represent when I'm free from military duty, because I'm still active duty, just coming back from Africa from 8 months tour, and with the International Organization for Migration, with OCHA, and with the University of Edinburgh, and very importantly, the simulation industry, like MASA. Next slide, please.
One moment. One moment, please, while we'll continue to work on, we'll have the slides here and they'll show here. When we go. So for those that don't have the agenda in front as the slides are being called up, Walter's presentation is in collaboration with two others. It's an artificial intelligence and simulation approach to climate, conflict, migration-driven security issues. I look forward. This sounds like a very practical application of what we've talked about already. Walter, over to you.
Yeah, this research looks for new approach, new ideas to support the shift from the response to a disaster, to emergency, to anticipatory action. Also, we want to explore tools to plan and respond to present and future threats. We all already remember the experience in 2020 about the COVID. So maybe we would like to catch the black swan and to anticipate something that is going to become a major threat. In the framework of OCHA, Humanitarian Networks and Partnerships Weeks, we have discussed with the humanitarian actors the need for smarter humanitarian responses. So we organized 2 sessions last year and this year, just 1 month ago, in Geneva. In particular, we wanted to explore the potential for using the modeling simulation constructive that is widely used in the military since many years, I think decades, for the humanitarian organizations. Also because now they are user-friendly, they are tools that are not so expensive like in the past and not so time-consuming. Next slide, please. Okay, this in the slide you can see what is a conceptual framework linking together these 3 phenomena: the climate crisis, the conflict, and migration. What is I call it the bad nexus. The bad nexus. There are not so many researches in literature about the connection between climate and conflict and migration, but there is evidence, especially for people residents living in the Horn of Africa, and even for humanitarian actors working in Africa, that these countries are very vulnerable to the climate change, but they are also most of them, they are also involved in a conflict, internal conflict, in terrorism, violence. In fact, many students and the scholars they consider the climate as a conflict multiplier for violence and for conflict. But this is not theory for us. I come after 8 months experience in Africa, and despite my job was to advise at the strategic level, the ministry, the staff, then about operations regarding conflict. Then we just living there, you realize that the biggest problem is the poverty, is the drought, is the climate at the end. Next slide, please. So this is.
Okay, should be there, yeah.
Hmm?
And so it takes a little
So this is the case of Somalia, for example. In Somalia, we have more than 6 million people affected by drought emergency. Almost 800,000 have been displaced in the last months, looking for water, for food, for pasture. 60% of the Somali population lives working with as a pastoralist. They are nomadic clans. And in the past, they used to export to Saudi Arabia, to the Gulf states. But after 4 years, this is the rainy season. It's almost the end of the rainy season in Somalia, and in June, early June, and we experienced very few days of rain. So even this last rainy season is not enough to restore the. And what is the link? The link is very evident. The link between the drought and the military situation. Why? Because the Al-Shabaab is Al-Qaeda affiliate. They exploit the situation. They are very cleverly. They control the few water resources, the rural areas. They impose taxes to the people that want to use water. And it's a big opportunity for them also to gain influence, to control these areas. And even they can afford to distribute some humanitarian aid where of course, the government will not go for security reasons. They tax for water. This, a lot of people has to leave the animals, or they bring the animals to the capital or other cities, looking for food in the garbage. A lot of people is unemployed. What do? They are recruited. It's or maybe they work part time. In the morning, you feel that you are dealing with a government official. In the afternoon, they have to collaborate with Al-Shabaab. Even enterprises, they have to pay taxes to Al-Shabaab. So they pay double. They pay the government and they pay the Al-Shabaab, and of course the corruption. So this is not a war that you can win on the battlefield. Nigeria is another case. We started actually the research in Nigeria, focusing on Borno, Northeast, selecting some requirements from the International Organization for Migration, dealing with camps. Here we have 40% of the IDPs, internally displaced people, living in camps or let's say settings like camps. But this and other, of course, 60% of the other, almost 2 million, they live in local communities. Here is also a big problem in camps, in the management of camps for the fire, because they use wood for cooking. They use the high temperature help in expanding these fires, degrading the environment. There are of course floods, droughts, again disease outbreaks. All these problems create a lot of difficulties in managing IDP camps. And IOM identified some requirements for smarter tools for early warning, for new approaches to cope with the climate change. They asked us to investigate if a tool that is used at strategic level could be used even to the sub-tactical level, to the level of camps. And here it is. So we tested what is called the medical intelligence platform. It's from Expert AI. It's a tool that is able to understand whatever is written or audio in the way that people think. So it's able to scan the web, even the dark web, according to the user's request. And it's a hybrid engine. It's a hybrid, why? Because it uses ontologies, like a medical ontologies, but it uses also natural language understanding and machine learning. So you can decide how to calibrate the tool. So what we did? We provided this tool for a couple of months to IOM in Nigeria to test at the tactical level. This is a strategic, of course, strategic tool. But what to do with this actionable intelligence coming from an AI platform? Well, while the MIP, the medical intelligence platform, is able to help in early detection of diseases, it is not all that, because the ability of the system, of course, depends from the users. So we use it also to detect terrorist threats. In Nigeria, the big problem is, especially in Northeast, is not only the medical problem, but is the terrorists. ISWAP, Boko Haram, targeting humanitarian workers, targeting camps, targeting students, even students. So we use the intelligence detected and analyzed by the MIP to inject it in a constructive modeling simulation tool that is very close to the SWORD tool used by the military. And synergy works in 4 steps. Let's say the first at the beginning, the entities, the agents, the simulation agents that are provided by the artificial intelligence engine, they perceive the scenario, they perceive their own abilities, they perceive the terrain, they build knowledge about threats and about the environment. Second step, they have to take action compared with what is the mission, their mission. They implement the action, and after the outcomes of their actions, we measure the effects and we update the scenario. At this stage, in the scenario update, we can also inject information coming from in real time, for example, from the medical intelligence platform. Like this way, I show you. Yeah. So we simulated a campaign for distribution of vaccine in Northeast Nigeria. We built that is a typical SWORD or synergy scenario in Masa, and the MIP, the medical intelligence platform, was able to discover also camps that are not in the official list. So the illegal settings or other places where people live. Also the threats. So if in real time there were coming news about from tweets or from Facebook or from radio messages or any other text about the presence of a threat, like for example armed groups in motorcycles. This information was taken in consideration by the simulator in order to analyze the scenario again and to select the best itinerary in order to fulfill the mission. In some cases, it is not only the threat from the terrorists, but also landslides, or it could be blocked roads for military checkpoints or some other reasons. In this case, for some camps that were really isolated, we also experimented the use of cargo drones, that is industrial drones modified to bring a payload or for medicines. So this created the opportunity for a cycle mixing together reality with training and again with the reality. So you have real news coming in almost real time, and you have a simulation system that is that has its own scenario that already built. But in this way, we were able to update the scenario. So what is the conclusion? And to make it shorter, what is the value? The value of artificial intelligence and simulation in humanitarian action. As I said, there is a shift. We are working for shifting from the response for reaction to a crisis to anticipatory action. In this case, we realized that we can have a faster decision. Why? Because we have early detection of a disease that is coming, that has been discovered somewhere. We have a warning coming from a landslide or something that people has detected, or they have sent a message or a tweet. This is helping in preparedness and also in response. And most important, the quality of training. So we are able to improve the quality of the training that is in the way that the military do. The military is doing this since at least 30 years. So the military uses constructive simulation for improving the quality of training of staff of headquarters. But this was not something easy to implement in humanitarian organizations due to the lack of manpower, to the lack of resources. Now these tools are becoming really user-friendly. So at the end, better prepared decision makers generate less risk of error. And this is my conclusion.
Very good. Thank you, Walter. Thank you. Excellent comments. Just a couple of brief notes from just actually quotes. So anticipatory disaster management or security operations.
Yeah.
Anticipatory.
Yeah, this comes, of course, from the use of predictive tools. And also in the past, working also with the crisis management and disaster response Center of Excellence. I was very happy to collaborate in the past years. We were able to connect, to link the SWORD, the Master SWORD constructive simulation that is supported by artificial intelligence engine, with the external expert systems and predictive systems. In this way, you can have a really better situational understanding of what could happen. Also, strategic tools like the MIP, the Medical Intelligence Platform, can help in detecting even weak signals coming from people and from emotions, because that system is able to analyze almost 60 different emotions, and to perform a stylometric analysis in order to understand if the text was a fake, the text was written by a boy, by a lady, avoid losing time in analysis. This is done automatically.
Very good. Yeah. So the use of artificial intelligence and the modeling capabilities.
Yes. Still, of course, there is a challenge because this, of course, the private sector is happy to work with let's say the humanitarian sector but of course we need there is a need for donors in order to implement these capabilities, because we tested, for example, in Nigeria 2 months, but still of course it's important to have donors for implementing the capability.
Yeah, very good. Just a couple more notes that I catch up with. We'll come back during a question and answer period, but I like the term catching the black swan. So catching it before it happens, so that maybe.
Yeah, you remember the first symptoms when I remember the first days of February. I was in Geneva, speaking at at the OCHA conference, and I saw somebody with a face mask in the airport. Of course, they had we could disinfect the hands, but nobody was using face mask. You know, and a few days after, you know, the patient zero in Italy coming from China and so on. No? So if we would be so good in analysis to catch the black swan before something very big happening, that actually is impacted us for 2 years, and you can imagine how it impacted the humanitarian sector, because you know the disruption of air travels. So everything was done by local leaders in. Especially in Africa, in other countries, because international experts were not able to travel. And the economy, of course, the big impact on the economy that for lockdown and something like that.
Very good. Walter, thank you very much for your presentation. We have one more presentation, and then we'll return to the question and answer. If you might as well, would you care to stay and stay with us here?
Yeah.
Very good. So we're going to try one more time with one of our remote presenters. So Dr. Risto Chervenkov, are you online still, and can you hear us? Dr. Chervenkov, can you hear us? I think we were all hoping that the third time really would be the charm, but maybe not. We'll see.
Do you hear me? Да?
Yes, Hristo.
Here we go.
Hello, do you see my screen?
Yes, we can see your screen.
Yes, thank you very much for the second opinion to present my presentation. Apologize for the delay. The title of the presentation is Applicability of the CHIRPS precipitation product in the regional climatology of Southeast Europe, and this is a common work with our colleague Kirill Slavu from National Institute of Meteorology and Hydrology. First of all, a short outline of the presentation. In the preface, our motivation for the consideration of the CHIRPS precipitation product and the goals of the study. Second, the short description of this product and the yields, which is used as a reference data set. The used methodology is placed in point 3. The core of the presentation is in point 4, the performed calculations and the obtained results, the summary and the conclusions, and finally, of course, the acknowledgement. I will not read the whole text. As you know, the precipitation is key component of the global water cycle and is essential climate variable in the terms of the climatology, with key importance of wide range of climatological but not so climatological applications, which are listed here. And that's why the analysis of the climate variability and trends require long-term, temporally consistent, in particular homogeneous and reliable precipitation time series. And it's important, essential to know the precipitation distribution, especially over our regions. Hence, the agricultural crop production is the main economical sector. Nowadays, the satellite-based precipitation estimates are increasingly utilized in various geophysical applications, including regional climatology. And CHIRP stands out for climate hazards group infrared precipitation with stations. It's a quasi-global product that, due to its high spatial and temporal resolution, long-term temporal coverage, and relatively low latency, has the potential to become a multi-purpose precipitation data set. And this one is dedicated to the current study. We have examined the applicability of this product for the whole recent time span of the product of 40 years. Nevertheless, to our knowledge, the study investigating the performance of CHIRP's precipitation data set over our region by using new available ground-based observation is still absent. There is similar studies over different parts of the world, Brazil, Central and North Africa, but there is no such study over the Balkans. Unlike other parts of Europe, there is a lack of free available national to regional assimilated data sets of ECVs, which is additional motivator of our work. This is a short, not very short indeed, description of the CHIRPs. From conceptual point of view, the CHIRPs tries to utilize the previous successful experience utilizing the plenty of satellite-based products like the atmospheric administration rainfall estimate, the African rainfall climatology, and TARCAT. And CHIRPS uses a smart interpolation approach working with anomalies from high-resolution climatology. It incorporates station data in two-phase process, producing two unique products. Actually, and shortly speaking, the CHIRPS tries to blend in optimal way satellite and other data with ground-based observations. At the present and on global scale, there is important gap in types of gridded precipitation data sets. There are data sets with long period of record with very long latency, like GPCC, the best precipitation inventory of the world, which are highly curated, and serial products. And there are low latency precipitation estimates based solely on satellite information, as for example, the UNETSAT HashSAF products. Both groups have merits and drawbacks, and CHIRPS tries to fulfill this gap. It has been explicitly designed to fill this gap, providing blended GOG satellite precipitation estimates that covers the most global land regions. Now, two features. The feature above, there is it is shown the main component of the production chain and the data flow between the different modules. And on the feature below is shown is a map showing the wettest 3-month season based on the CHIRPS modification. Actually, this feature, the feature below shows the coverage of the product. EOPS is well known in our community, and those have not to be described in detail. I would mention that the EOPS is de facto standard reference for evaluating the regional climate models participating in the EuroCordex initiative. But it's also frequently used by us and other groups from various other regional climatological applications. Recently comparing version 19 with regional data sets, Van Hauer et al. Found that the former reproduces the pattern of the daily precipitation climate well in all three considered regions, Alps, Carpathians, and Fennoscandia.
Can you hear us, sir? The technical difficulty here, maybe the computer is on his end is frozen. Dr. Chervenkov, can you hear us? Try for just another brief moment here, and then we might move to our final presenter. With the recording link. Dr. Chervenkov, I don't think you can hear us. Thank you very much for the presentation so far. I know that we'll look for another way to ensure that we get the remainder of your research presented and the value of your contribution. So thank you. If you can't hear us, thank you for what you've been able to give to us so far today. For those in the room and those online that are still able to participate, over the next minute or so here, we're going to make a switch to one more presentation. This is by Professor Dr. Yavor Chapanov. This will be a recorded presentation. We had, again, to resolve some of the technical difficulties we had earlier this morning. So with that, if we can begin with a recorded presentation, we're set here. May I ask, is there any sound associated with the recording, or is it just the slides?
Excuse me, do you can hear me? Do you hear me? Cara.
Online participants can hear you, but probably in the studio they don't.
Do you can see my screen?
Yes.
Yes, I continue.
Yes,
There was a connection failure. Now
welcome back.
Thank you. Thank you, Mr. Chairman. The next slide, please.
Sir, if you would be able to use this, the next 5 minutes to wrap up your presentation.
Yes, but yes, first of all, statistical scores, the red lines of the grid space and the domain. Actually, the data results for some widely used statistical measures like the bias, the root mean square error, and the Pearson correlation coefficient. It can be seen that the bias, despite the random oscillations during these 40 years, the mean value is close to the perfect match, namely 0. The second one, the statistical scores over the time, what can be stated here. There are no, at least not obvious special distribution of these measures. The error, the disagreement seems randomly distributed. There are some local features. For example, the relatively high disagreement over the Adriatic coast and over the Dinaric Alps, and the table below shows the spatially and temporally averaged values of the considered quantities. Now, this figure shows the multi-year monthly mean precipitation. It's mean for the whole 40 years long period. This is the multi-year monthly means. What is apparent here, the both data sets describes relatively good the main features of the precipitation distribution, but still the difference, the disagreement between them, and actually the error of the chirps is relatively high. The bias is traditionally shown in the bias is relative in respect to the reference, and as can be seen, the prevailing bias is positive. This is for the second half of the year, almost generally the same picture. And finally, the results for some key precipitation-based climate indices, namely the number of the consecutive dry days, the consecutive wet days, the 95th percentile of the precipitation, and the number of days with precipitation above 10 millimeter. It can be seen here that the disagreement is significant, non-neglectable, in direction overestimation. Namely, the chirps overestimates the reference significantly. And actually, there is a difference between the estimation of the mean state and the estimation of the extremes, which could be rooted only of the statistical distribution of the precipitation. And actually, these histograms shows the areal average number of days with corresponding precipitation sums. And the intercept above shows the upper tail, namely the upper tail which is responsible for the heavy precipitation. This histogram shows significant disagreement in the upper tail, demonstrating that the tail of the chirps is significantly higher. It means here the precipitation over 10 millimeter cases with precipitation over 10 millimeter is much more frequent in the chips comparing with EOPS. And now the conclusions, I will not read all of them, but the revealing non-negligible and practical systematical overestimation of the multi-year monthly means of the precipitation sums is the most important conclusion and actually outcome of the study. And based on this result, we can conclude that the applicability of the CHIRPS precipitation product in the regional climatology of Southeast Europe could be judged problematic despite our initial hopes. And what else? Maybe this disagreement and failure of the CHIRPS indeed could be rooted to several factors, but the most sufficient seems the lack of ground-based stations, data from them, including the blending procedure, and that's why we hope that inclusion of such data in the future version of the product will improve its quality. The CHIRPS reveals also some local specifics. For example, the relatively high disagreement over the Dinaric Alps, but this result should be not generalized for the whole mountains. Hence, the results for the Carpathian Ridge and the mountains over southeast Bulgaria are close to the background values. And finally, our study has implications for further precipitation product development and refinement, and can provide guidance for alternative choice of precipitation data for the regional geophysical community. Also, the colleagues participating in this conference. We would acknowledge the CHIRPS. I should underline again that this product is free, available, free of charge, free downloadable from the internet, and thanks to this program, which is also organizer of this conference. And thank you for your attention.
Thank you, Dr. Chervenkov. Thank you for your patience too with the technology. You're very good about staying with us throughout. So thank you very much for your presentation.
Thank you for the second chance.
With time, we will pass on the question and answer period. But I want to do a quick summary session summary of our panel session. We've been going for several hours now, and we've hit some very key points when we talk about the title of this session, which is climate change and security implications. So in a brief summary, I really want to look back to thank Lieutenant Colonel and Associate Professor Petrovsky to talk about North Macedonia and issues around climate security and implications in North Macedonia. It turns out as a very good case study for how we think both nationally and regionally, and then as an alliance on the impacts, security implications specifically of climate change. Thank you, Alexander. Dr. Bocheva, thank you very much, Lilia, for your presentation as well. That was extensive data over 30-year data sets, explain the Köppen-Geiger model and the value of that model and the data application. Very thorough research, and the visualization I thought was most helpful as you looked at climate change in Bulgaria. Petya and Dr. Belov, thank you very much for your work on road surfaces in Bulgaria, and again, assessing the locations, the black ice situation, and the safety implications there. After our short break, Dr. Popov, thank you, Risto, for talking about heat waves and the challenges associated with those. And then remembering for all of us that Bulgaria finished fourth that year in the World Cup, in the 1994-95 season. Dr. Ivanov, again, addressing energy potential, thoughts of wind and solar power, again, as we look at climate change and what that might do for our energy resources. Mr. Ristov, thank you, sorry. The freeze-thaw research, again, the implications for us there. And then nearly finally, for the morning session, Professor Pashova talking about sea level rise and how we think about, we didn't talk much because we didn't have much of a question answer period, but the implications for maritime infrastructure in the Black Sea and how defense forces could use that. And then this afternoon, some great discussions. Walter, thank you for your presentation. Let me just stop there. But another excellent presentation on something at a very tactical level, very, very useful. So for everyone, thank you very much for participating in the panel. Let me turn it over now to the director. And for all of you, again, thank you very much. For those who are present and presented earlier, if you could join us on stage.
Yes, please.
Please join us up.
Please come join to us. It's a great pleasure for me and honor, of course, especially for Walter. David, let's start with him. I think that you are, after me, the person who has more iteration from CMDR COE conferences. Please come here. From that perspective, Walter, again,
thank you very much.
Thank you very much for your participation. And this is for you. Please, Steve, come here. Come here to take a picture of you too. Of course, you are. What? We finished the. You can do all. No, I need to. Okay. Thank you. One more. Listen, please. Thank you. Thank you very much. Thank you very much again, Walter. Thank you, Walter. This Dr. Please join us just for one short picture. And thank you for your participation again. Thank you. Thank you very much. Thank you. It's a pleasure to meet you. It's a great pleasure. You are our editorial board now officially for participation again.
Thank you. And we have Lilia as well. Is she?
Lilia?
She's hiding back there now.
Lilia?
No. Okay.
After coffee break.
After the coffee break.
After the coffee break. And of course, to our moderator, this picture to Steve. Thank you very much for your coming again and to see you again here in the come on. Thank you. Thank you. Thanks very much.
Sirs, ladies and gentlemen, thank you for coming back timely from this coffee break. And now I would like to give the floor to Professor Georgi Gadzev, and Professor will be the moderator for the panel number 3 of our conference with the title Air Pollution and Health. Professor, please, the floor is yours.
Good afternoon to everyone. Today I will start the session Air Pollution and Health, and with 2 presentations. And tomorrow we will continue the session with the other 8 presentations, I think. Today the both presentations will be in the context of the urban air pollution in Sofia city. The first one is for the transport emission from Sofia streets, and the second is for the temporal variation of black carbon in Sofia. I would like to give the floor to first presenter, Dr. Angel Burov.
Thank you for the opportunity. I'll share my screen. Do you see my screen?
Yes.
Okay, thank you. So greetings to everyone. I'm glad to have the opportunity to present our work. It's a preliminary stage in a project funded by the Bulgarian National Science Fund. We have also some experience before that, which was more, let's say, experimental. So, yes, in the introduction, we would say that certainly in bigger cities globally today, there is a cocktail of sources of air pollution, and people are exposed to many risks associated with the different chemical species, the fine and ultrafine particles, including the sometimes neglected nitrogen dioxide, which is very much related with transport sources. The challenge of air pollution is the global level addressed by 2 of the Sustainable Development Goals and 3 targets, also the 3 related indicators, including at the global level. We already know that the environmental risks are not the biggest ones as global burden of disease. There are also the metabolic and behavioral risks, which are the behavioral ones are the biggest. But at the same time, it's interesting to say that in the urban way of living and the urban environment, the environment and behavior of people can be very much related. And they're very much related to the occupation and way of living, to the different income groups, which is sometimes related with segregation in space, and the more specific physical configuration, which can differ significantly from one part of the city to another. Sofia's case study, here we have seasonal climate extremes, uneven topography, diverse land cover. It's a city situated in forested region with high ratio of urban green compared to other cities in the, let's say, temperate climate zone. And there is at the same time compact development with heat islands and urban street canyons, which are not always the classical ones. They're a little bit more non-symmetrical. The building morphology types and the street network patterns, they have varying degrees of roughness and porosity because of that, let's say, different type of urban street canyon developments. including the more complex-oriented housing estate developments, which dominated the second half of the 20th century in Sofia. In the last 2 or 3 decades, there is growing polycentricity, densification of secondary mixed-use centers, and parallel advantaged or disadvantaged new peripheral suburban development, which generally is falling into the category of muddy development, with very big brown areas of not well accompanying the development public works. According to that, there is also lagging behind or sometimes low quality public rail and road works and maintenance. I mentioned here the rail transport because it's developing as an underground, but the general rail facilities on the ground are very much lagging behind, and currently they're being rehabilitated. The model split has already fallen into the so-called vicious cycle of the growing motorization rate and the deepening car dependence. The development of public transport is not always in the best way, so there are a lot of critiques around it. There are selective conditions for shared mobility models and very much neglected light mobility and access opportunities in terms of pedestrian, cycling, and other electric-driven micromobility. In terms of inventories, currently for Sofia, there haven't been inventories which go beyond the tier 1 level, which are more basic for screening purposes inventories. So we could say this is a great gap, and it is very much misleading the air pollution policy in Sofia. Spatial scenarios haven't been also developed and included even for, let's say, measures like low emission zones, which are currently under development, but they're not spatial, they're more like quantitative scenarios, which don't provide good ground for comparison from one part to another in the city. And there is great lack of exposure estimates to air pollution beyond the global reports for Bulgarian cities like Sofia, which are very rough estimates. So the aim of our research is to test a more complete methodology for linking air pollution, urban development, and health. Here in this presentation, we show the first steps in the inventory, scenarios, and exposure setting, but there is parallel work on measurement, dispersion modeling, and epidemiological survey, which is also included in the research project work packages. The great challenge at the base is that traffic and fleet data come from various sources, but with not very detailed structure, and there is lack of integrity and many methodological mismatches in the data gathering formats and let's say integrity of the data as a whole. There is scarce public access to traffic count data from the municipal sources, although there are such, and that's a great challenge for the more open policy of the municipality. There is also lack of municipal transport model on which air pollution inventories could be grounded. So that's a great obstacle. Still, there is valuable open access data from Sofia Plan, which made great efforts to provide such. There are our own data gathering approaches, which were light and supportive, and very intensive processing to match the diverse geometry, attribute data, and methods of gathering the different data sources. So generally, we need time and cost efficient approach to perform those steps by using public accessible data and open source software in order not only to outbeat the spendings which are made by the usually the local authorities, but also to provide conditions for, let's say, making choices beyond the limits of the modeling approaches up to date. The rapid traffic modeling is based on diverse characteristics of the street network and the spatial development of Sofia. We use data interpolation in QGIS and machine learning regression models in Python. A relatively large proportion of the missing data requires pre-processing, as I mentioned, and phased imputation using a well-trained multivariable regression to select optimally the parameters. They have different role in the primary and secondary street network. Generally, the primary is much better represented by traffic counts. And so we need to separate them in order to propagate down the hierarchy in terms of predictions. Further on, there have been georeferencing instances, joins and relates, heat maps, and interpolation with inverse distance weighted and thin interpolation approaches in order to smear the point data, which is very scarce. The factors which we used, roads and street classes, capacity of those, traffic counts, tracking and estimates from different sources, both from the municipality but also from open access projects and commercial sources. Population density, functions, space in taxi integration and choice, and the Euclidean distance are used among the factors. The optimal combination is reached by correlation methods, including the analysis, which we are still testing and we're trying to improve. There has been need for normalization, calibration, clustering of for usage of the machine learning techniques, including modified linear lasso regressors, random forest algorithm, and multi-layer perceptrons, and others, which are still we are still experimenting with them. The fleet scenario development is being subdivided in three-dimensional categories by, let's say, an analytical hierarchical process in order to gain, to make use the different sources of data which are not non-consistent. So we try to make it, let's say, more complex, because one of the softwares uses around 800 categories of fleet categories. So it's very specific, but it provides good ground for comparison and then differentiating measures. The emission scenarios based on predefined general assumptions for fleet composition changes in the more basic Euro categories and eco categories, which include Euro categories based on age, and other categories, subcategories based on weight and power of power types of the fleet. We calculate them first in Excel, and then we include them in the software called EMIT of the so-called CERC, which is also the ADMS software producer. So there are different years which are compared, and different scenarios based on proposals for ongoing proposals which are changing from the municipality, from consultants of the municipality, and also from advocacy groups. The activity modeling is trying to differentiate activities in space and time. It stems from land use and functional analysis of points of interest. It is grounded on density, built-up area, and plot area in order to accumulate the number of users at one specific point in space and also in time. Periods which are defined by different schedules and patterns of usage of different facilities and points of interest. It is based on logic, not on observation, because such observation data is commercial and not very easily accessible. Further on, the urban morphology modeling is based on the calculations from the Street Canyon tool from the same producer of the EMIT software and the ADMS software. It is performed in dark map environment. And there is also usage of the so-called UMap plugin, which is accessible via QGIS as plugin, including for the digital surface model and sky view factors and other morphology related parameters, which are used for analytical purposes. The results, the morphology, you can see here a more synthesized map of the urban street canyons based on height, width, and length aspect ratio, combined for both sides, left and right. The phenomenon is spreading beyond the central part of the city towards more concentrated housing estates and secondary centers, but also other tertiary centers, which are formed in the recent years around big facilities, commercial and leisure facilities. The results have very good relation with the urban street canyons. We have the historical core city, which is very typical and classical in terms of urban street canyons. But also we have the concentrated secondary centers in between more populous and prosperous, let's say, neighborhoods, where is the usual market concentration of not only offices, but also commercial areas and leisure areas. So they are currently shaping very much the traffic and the congestion in the city. And also tertiary centers provide grounds for concentration of activities, which are usually very much attached to the more high density socialist housing estates, which are already infilled with additional housing and commercial activities in the last 20 years, with construction happening usually around the underground and other public infrastructure. The traffic, we found that there is very decent correlation, but also noisy data and need for smoothing. The random forest algorithm up to now is found to be an excellent choice. And the correlation is very high, more than 0.9. Still there are data gaps which are reflecting upon the quality of the distribution of traffic. Generally, we can say that transit and congested boulevards, which are both radial and tangential, denser networks of service streets in the center and at some of the secondary centers are those with the highest share of emissions. We're still performing new instances of calculations in order to reach, let's say, more nice results in terms of correlation. We have a sample which is going to be presented tomorrow about Tarkovsky Urban Street Canyon and areas around, which is a typical classical urban street canyon. There are scenarios for 2026 and 30 based on the baseline scenario from 2018. And for the discussion, I would say that we start to understand better the link between emissions generation and exposure settings. And there is high degree of risks which change under different conditions based on geomorphology and urban morphology, but also vast artificial surface and canyons, all together with more intensive arteries, transport arteries, sometimes with higher speed traffic, but sometimes with more congested traffic, and the related public life, which is very close nearby to those areas and inside of such canyons or lower lying lands. As we can see, here is a comparison of 3 advocacy proposals for low emission zone, which try to grasp with areas which are low lying, but all together with that, there are already rings which can provide some of the traffic to go out of those areas, especially the traffic which is with lower performance in terms of air pollution. We see that not only the historical city center, but also some other sub-centers and extensions of the center are very much concentrated in terms of urban street canyons. And this is all together matching with not only with significant traffic, but also with concentration of activities. So many people are exposed to those different conditions which combine, and they provoke not only the immune system, but also sometimes they lead to persistent attacks towards the health of dwellers and users of those areas. So some of those exposures are all year round, and they're also not only in established but also in emerging hotspots. So we have to take in mind that we cannot cope with the traffic-related emissions only by having a small area traffic emission zone. We have to cope with that very soon in the whole city, but still we can differentiate the impacts over certain areas through wise and smart measures, and also through more holistic and long-term urban development model in order to prevent public health, not only for today, but also for the years to come. It's more hard to prevent health today indeed, but that's a crucial question, because today becomes tomorrow, and we continue to lag behind other cities in terms of wise management of this challenge, especially in terms of the higher degree of let's say aging of our society, but also specific climate which provokes a harder seasonal attack towards our health system. And altogether with that, we have the post-COVID impact. So we have to be very much aware about those challenges, and to be more not only competitive, but also ambitious in terms of air pollution management, not just to follow the leaders, but to be the leader in that. So thank you for the attention, and thanks to the Bulgarian National Science Fund. As part of this work is already funded by a project which is called Development of a Methodology for Air Quality and Human Health Risk Assessment in urban areas. Also thanks to the Sofia University team, Renata Dimitrova and Margaret Velizarova, for their support in terms of hardware and software, but also the discussions we have and the joint work up to now. The Environmental Association Zazemyata and the Clean Air Fund, which have supported preliminary studies and experiments with some simulations, which were carried out with their support, and several colleagues, including Dmitry Trifonov, Vasil Magirsky, and Teodora Gotsova, which took part in preliminary data mining and experiments. So thank you.
Thank you for presentations. And I'll give the floor to Dr. Elena Hristova.
Good afternoon, everybody. For me, it's a pleasure to be here and to present our work.
I'm going to talk about the temporary variation of black carbon in the urban air particulate matter in Sofia. My presentation will follow the listed outliers on the screen. Every one of us maybe know what is the air aerosols, but that is the liquid or solid particles suspended in the gaseous media. They vary depending of the region original or their chemical components. One of the main light absorbing components, that is the black carbon. That is carbonaceous aerosols formed through the incomplete combustion process, which have the unique combination of these listed physical properties. There is no universal acceptance definition for the black carbon. This is depends of the measurement techniques. But in our presentation, I will use this term black carbon. Why we focus on this substance? Because this is a significant portion of the fine particulate matter is comprised by black carbon. Also, for its negative impacts not only on the human health but also on the climate. And finally, last but not least, is the lack of observations of black carbon in Bulgaria. With the main objective of our study is to present the time variations of black carbon concentration in fine particulate matter in Sofia from 1 year measurements. Our sampling was organized at Central Meteorological Observatory at National Institute of Meteorology, with following the US standard for sampling in the period from June 2020 to July 2021. All collected filters were analyzed for black carbon used by multi-wavelength absorption black instrument, which is a relative new research instrument developed at Austrian Nuclear Science and Technology Organization. This instrument measures light absorbing absorption at 7 different wavelengths, which give a possibility to differentiate the contribution of sources such as biomass burning and motor vehicles. I will not stop in the calculation, but to obtain the mass concentration of black carbon, we follow 3 main steps. Here you can see the time variation of obtained concentration of PM2.5 in our study period, which you can see the seasonal pattern with maximum during the winters and cold periods of the study period, and minimum during the warm period. There are no strict daily limit value under European Directive for Air Quality, but there is a recommended level which will not to be exceeded from WHO. What we observed that almost 30% of the daily PM concentration exceed these levels in Sofia for this study period. The same seasonal pattern we observed also for black carbon concentrations. And also you can see here the daily variation of black carbon concentration and BC-PM ratio. This ratio gives information what portion of the PM2.5 is black carbon. You can see here how is different in a very big range. But on the average value, this is around 20%, which is comparable with the other European countries. In order to see the influence on traffic intensity around our sampling site, we calculated the mean daily value of both species for weekdays. Here you can see that there is increase in the concentration of PM2.5 and black carbon from Monday to Friday, and of course decrease in concentration during the weekend days, because we know that Sunday is Sofia less traffic intensive. Instead, this air pollution is strongly connected with the meteorological conditions and topography. Here you can see we try to find how the quantity of precipitation influence of the both concentration of PC and PM. And you can see that the maximum concentration of both species we observe during the days without precipitation, there is decreasing in concentration with increase of quantity of precipitation, daily precipitation, which is more pronounced for PM concentration and not so for black carbon. When we have only one sample site or monitoring station, most of the groups want to see how to be the spatial distribution of the air and also or over Bulgaria. So we try to compare our results for the modeling data from European Air Quality System at the Copernicus Atmospheric Monitoring Service comes. Which this model is an ensemble model with from 9 different chemical transport models. Future in when we discuss for investigate deeply in the CMAIN's specific episode, we use also for long range transport analysis high split. On this slide, I'm presenting a special distribution of black carbon PM2.5 over the country for January 2025 based on the results from the CAMS model. You can see that the regions with the higher BC and PM concentration are mainly outside of the country, but there are also a hotspot in the country around the Sofia and also in lowlands of southern Bulgaria. On the next slide, I compare the daily mean variation concentration of black carbon and PM observed to model by this CAMS model. And what we're surprised to see that when we have the highest concentration of PM and black carbon, the model underestimates our data in opposite for the other days. But on the mean value, you can see that the black carbon concentration is a little overestimated, around 29%. And the opposite, that PM concentration is underestimated by this model. But we have to take in mind that the resolution of the model is 25 kilometers, and we measure only in 1 point. We investigated also as an additional study 3 main specific episodes with a high elevated concentration of our species. The first one is on 27th of November, when we measured the highest concentration of PM2.5 black concentration. This was the day with deep inversion, which supported by the vertical profile at temperature for sandic data, which give us possibility to take that to say that these days this concentration is mainly influenced from local emission sources like traffic and residential heating. The second case that we observed is 12th of March. What we happen on this day, we have a sharp increase of both concentration. this sharp increase also was simulated by the CAMS models. And after that, we wanted to look what is the regional influence, and saw that in the region of west part of from Bulgaria, there was intensive fires, which is supported by the map from satellites information from NASA. The third period was the end of July, when we have 4 days with permanent, almost the same, without changes or small changes of the both concentration. This also was simulated with these CAMS models. These 4 days were probably influenced for two events on large scale. One is the Sahara dust influence, supported by the maps from this concentration from Barcelona models, and also the forest fires, which were very intensive from the south of Italy and north from north border of Bulgaria. And in conclusion, I would like to say that this is the first, for the first time in Bulgaria, fine particulate matter were analyzed for black carbon content. Results shows the seasonal pattern for both species. Also, the mean contribution of BC to PM2.5 is around 20%, which is comparable with the other European countries. Also, the high correlation between PM and black carbon it suggested that the domination of fuel combustion to PM 2.5 is yes. Sorry. Also, we see that lower PC concentration during weekend days in comparison with weekdays clearly decreased trends with increasing of precipitation amounts. And from the comparison of model and observed data, we observed that PM 2.5 was underestimated, and black carbon was overestimated. We also believe that our data we will filling the gaps of relevant black carbon observation in our part of the Europe. I would like to say that this study is ongoing. We continue to sampling and to analyzing, and to say that all data are in frame of our project Carbo Aerosol. Thank you very much.
Thank you. Is there any questions?
Dr. Gadjev, would you like to sum up the session?
I would like to ask Dr. Borov, can it show his presentations, the conclusion?
Dr. Borov, can you show us the conclusion of your presentation?
Can you see the presentation?
Not now.
I'm sharing, but...
Okay, I'll ask you.
Do you see it now?
Yes, yes.
Okay.
What are these hotspots in the map? Do you know what are
Yeah, the hotspots, these are places of concentration of activity. Let's say people. Specifically here, these are people with vehicles, because it was this type of estimation based on both population density, but also presence of people during the day. So it's kind of 20-hour mean presence of people, because it differs during the night, during the day, and that's kind of synthesis of the presence of people.
Because some of these points, I think, are near to the malls of Sofia.
Yeah, certainly, yeah. It's because also of their very high surface in terms of offices and leisure space and shopping, which is estimated in our model. It's logical model. It's not based on, as I mentioned, it's described here. There's also subdivisions of different categories of how many people per how much space are present at certain facility during the times when it's working, because it can be very much adjusted in terms of activity, which is not that usual, or it can be also adjusted based on events, because some spaces like the parks and gardens can be very empty usually, but sometimes in peak months like May and September, they host so many activities that there are plenty of people. So this is still work to be done by us, because in order to say, let's say, to compare episodes of pollution with times of activity in terms of days or weeks or typical days, etc. We need to do a little bit more work in order to have it as a proxy, because it's a model, and we can also try to link it with data for presence of people, but that's commercial data, and usually it's not provided that easily, even if you're ready to pay for it, because there are also privacy issues for that data. Yeah, so these are the hotspots, and certainly we call them secondary centers. They're also described in the master plan of Sofia, the general development plan, as such, and some of those centers didn't develop that much in the last 10 or 20 years, but the ones which were mostly developed are in this arc, let's say, which is the southern arc, both connecting them with the airport and Tsarigradsko Shosei Boulevard, but also the one which is around the Chernihiv Boulevard and Bulgaria Boulevard. So these are certainly secondary centers which emerged in the last, let's say, 10 years, and they predefined the traffic patterns, which were before that more monocentric oriented, and now they're dispersed around those areas, with very often congestion happening along Tsarigradsko Shosei, for instance, in the morning in the outward direction, not in the inward, although in both directions very often also it happens. So it means that the capacity is over, and it means that the traffic is very big. Yes, it's a peak hour, but still it shows significant change in the patterns, and we should think more in the direction of those secondary centers and bigger areas in the city in terms of protecting health, because it's not enough to have protection only in the core of the city, as is now the discourse around the low emission zone. So that's certainly a challenge.
Thank you. And I will summarize these sessions. The first presentation was discussed the challenges of the air pollution emissions to associate with the human to the health risk. And the second presentation was discussed the measure concentration of black carbon in the National Institute of Meteorology and Hydrology, and also they was compared with the observation with the modeled concentrations, and this is for me.
Thank you very much, Professor, for your summing up, and we will welcome you tomorrow here in the center. Thank you very much. And now we can go smoothly to panel number 5, which is the last panel for today. And the name of the panel is Informatics, Remote Sensing, High Performance Computing. And I would like to ask Professor Syros for introducing himself and for being also the moderator for this panel.
Thank you very much. Well, Yursky, thanks for your invitation. It's a great pleasure to be here at the center. I'm new to the center. I do history of political thought, leadership, military political leadership. We're launching a new course this year on cultural property protection here at the center. And I'm very grateful for your invitation. Of course, the director has been extremely helpful, and Deputy Director Captain Zavaris. So it has been a pleasure to work with you since this past fall. So we're having panel 5, and we're having we're within schedule. So we're having in this panel this panel is about informatics, remote sensing, GIS, high performance computing. We'll have remote sensing informatics and models. The first paper will be by, it's a collective paper by Associate Professor Alexander Petrovsky, Professor Andrei Liev, Associate Professor Neda Donetsky, and Nikola Spazov. It's about application of drones in crisis management, support mobile application, and C4 IRS systems. The second paper is about atmospheric boundary layer height at marine and land air masses based on solar data by Dr. Damian Parantiev and Katerina Baratirova. The floor is yours.
Good afternoon. May I start with my presentation? Okay, my presentation was application of drones in crisis management supported by mobile application and C4IS systems. We did the job with my colleagues, and the purpose of this research paper is to understand which types of nowadays drones, depending on the purpose, can be used in different environments such as land, water, air, and space, and a wide range of possibilities, and that has created the conditions for applications in defense and security for the needs of the army and police. That's the original purpose in dealing with the crisis situations. And after that is in agriculture, construction, traffic, trade, communications, science, medicine, research, architecture, video and photography, geology, forestry, mining, oceanography, environmental management, sport, mapping, and etc. In collaboration with mobile applications and C4IR systems, it can be a powerful tool for saving people in different crisis management situations. First of all, that we needed to do is to make a classification of drones, and this was really exciting job, because we need to define all drones and to classify them, but by different purpose. We divided by several types of classification. First of all, we divided the purpose, what kind of purpose is using the drone. That means we divided in civil and commercial drones. The other part was military drones, and after that we divided by the mission they are conducting. That means the tactical drones, strategic drones, operational drones, and so on. The other part was the source of the energy that they are using and the resources that they needed. And we divided the drones driven by solar cells, battery cells, super capacitors, fuel cells, and kerosene. After that, we divided the environment where they are operating, and we have an underwater drones, surface drones, ground drones, and space drones. After that, another thing that is very important for the drones was the autonomy of the drones. That means the task allocation and scheduling, communications drones, motion planning, path planning drones, sensor fusions, trajectory generators drones, cooperative tactic drones. And the last one was the construction characteristic that we needed, and we divided them in 5 classes depending on that what are the constructions, and depending on the construction characteristic, which type of operations that can do, and how many time we can have them on rely on operation. We conducted research for all for nowadays conducted research, and we made these classifications of the drones. As we know, the drones are used for a wide range of applications, including wireless communication systems, which have the potential to provide cost-effective wireless connectivity for a wide variety of applications. The paper analyzed drones in order to select the most effective drone for use as a Wi-Fi stations in crisis situations. As we know, all drones are equipped with sensors. The most important of are accelerometer and altimeter. First is the monitoring on the flying altitude, while the other is there to detect the altitude of the user and anytime, but also to help lower and raise the drones. Can be equipped with various other sensors that help navigate and control the drone. Today it's possible to find a large number of drones on the market with different features and different purpose applications in agriculture and water management, medicine, transport, architecture, meteorology, geodesy, etc. The requirements for the characteristic of the drones for use in different situation operation in crisis situations are very uneven. Based on the above, the goal was to choose the most favorable alternative drone, which according to its characteristic would best meet the needs of solving the problem of mobile Wi-Fi station in crisis situation. The paper restricts the choice of air drones as a Wi-Fi station. The result of the research can be used during the further implementation of drones for support in different kinds of crisis situation. The complexity of choosing a drone as a Wi-Fi station has imposed the need to use a hybrid model of multi-criteria decision-making. Due to complexity of the research problem, a hybrid model consisting of two methods was defined: the fuzzy AHP analytical hierarchical process and the VICOR method, a multi-criteria compromise ranking method. The model that selected the most optimal solution, that's been drone model as a Wi-Fi station, that was the main purpose, in relation to the defined criteria is presented. The aim of this paper is to enable the selection of the most favorable alternative through the application of multi-criteria decision-making methods in order to implement them. The data used in the research were obtained on the basis of available literature and content analysis. In the first phase of the application, a hybrid mode of multi-criteria decision-making, the definition of criteria influencing the choice of most optimal solution drone was performed for application as Wi-Fi station in crisis situation. When defining the criteria for the selection of drones, it's necessary to include all relevant characteristics of the system to be optimized, which is further important for determining the weighting coefficients of the criteria. The criteria are defined on the basis of a study of the available literature and a view of the experts. The following criteria were identified on the basis of which drones were compared. The calculation of weight coefficients of the criteria was performed using the fuzzy EHP method, and the results are showing in this table too. This criteria: maximum speed, autonomy, maximum range, maximum flight altitude, price, maximum payload weight, reliability, and work conditions are explained in our scientific paper detail, and in the interest of time, I will not explaining them one by one. I will go further to see what's happening and how this multi-criteria will help us to choose which one of the drones that we have on the market now can be the most effective in application as a Wi-Fi station. Table 3 is an initial decision matrix where we are putting all need and all knowing information about the drones that we have now in the market, and using the quantification of qualitative linguistic criteria by bipolars scale, we get the table 4 quantitative solution matrix, where we get the all known informations, and using the formulas defined in VICOR method, results were obtained for these calculate values, and these calculate values give us the ranks of alternatives depending on the same value, and based on the application of a hybrid model of multi-criteria decision-making process using the AHP and VICOR method, is concluded that alternative A1 drones are the most favorable, and they will conduct the missions for Wi-Fi station. This is figure that shows a diagram of change in the rank of alternatives depending on the values after the application of the multi-criteria decision makers. This is the all values that we need according to them, and we see that A1 has the best results in every sector. That means that using this criteria, we can decide which kind of drone we can use in crisis situation. Another part of the research was implementing a mobile applications and C4I systems together, because the mobile applications, as we know that nowadays every one of us has a mobile phone. That means that we'll need to create application for the smartphones that will give an answers for in the prevention time, and during the crisis, and after solving the crisis. That's mean that every person can be located. We fulfill the application, we will know every person in which moment where is located. For the people who doesn't have smartphones, we can use a GPS locator instead of application, and that means that when something occur on the ground, there is a crisis situation, we will know exactly how many people are affected by them. And after that, with using of this application and Wi-Fi drones, we can make a more safer search and rescue operation that can be done on the ground. C4I systems are system that we use in the army. That is a system that give us command, control, communication, computer information system, reconnaissance, and surveillance. Geo-reconnaissance is determining specific type of information gathered for a visual observation or other detection methods, which give us information about the terrain, geographical elements of it, objects on the specific area that can help us to create a better picture for the resource and the enemy on the ground. And when we use for the civil purpose, we can find the people on the ground. So one of the ways of gathering data is by aerial photographers and space images, but the other one is from using drones. And our future steps is to implementing a part of models that will have opportunity directly through the using of artificial intelligence drones to learn by themselves on the ground. This means that they will not so dependable of the people who are working with them. At the end, I will say that this is a great opportunity and great tool for every situation on the ground. And we can use this hybrid model for multi-criteria decision making in different situations on the ground. And we can, with this application, we can affect more in the part of preparation during the crisis and in the part of conducting the crisis situations. That means that we can save more lives. The main motto for us is every person on the ground with mobile phone is a sensor, and we observe to predict, and we predict to prevent. That is our motto for this paper. Thank you for your attention. I try to be shortly and more effective in the interest of time.
Atmospheric boundary layer, height of the marine land layer, masses based on solar data. The floor is yours.
Thank you. Can you hear me?
Yes.
Okay. Hello, everyone. My name is Damian Barantiev, and I work as a researcher in Climate, Atmosphere, and Water Research Institute of Bulgaria Academy of Sciences. The topic which I will present is already mentioned: atmospheric boundary layer, height at marine and land air masses based on solar data. First of all, I would like to say that this study is supported by National Science Fund of Bulgaria with project with title Natural and Anthropogenic Factors on Climate Change Analysis of Global and Local Periodical Components and Long-Term Forecast. First, I will start I will start with study area and used equipment in this study. The study area is Meteorological Observatory Ahtopu, which is the southernmost coastal synoptic station in the operational network of Bulgarian National Weather Service. It is located about 400 meters inland at primary flat grassland. The coastline in the region is stretching out from northwest direction to southeast direction, and the coast is with steep about 10 meters high. The instrument, the data of the instrument which is used is from monostatic Doppler solar system, which is mounted on the roof of the administrative building. This is multi-frequency instrument which emit sounding waves in the atmosphere with a different frequency in different directions, and from the turbulent inhomogeneous in the atmosphere above the solar antenna, there is reflected signals back to the receiver of the solar, and that's how from the Doppler shift, from the Doppler shift, the wind profile and turbulent profiles are estimated. The instrument has vertical range up to 1000 meters, and the vertical resolution is 10 meters, starting from 30 meters above the ground level, and the time resolution is about is 10 minutes. Records are made every 10 minutes, and the average period is 20 minutes. So it's running averages. About the data availability and the applied analysis. On this table, you can see the availability of data during different months and during different years. The whole period which is studied is almost 8 years, from August 2008 to October 2016. On the table in percent, you can see a different availability during different months, and the effective vertical range of the solar during different months, which is marked with blue bars. The data availability is different during the first 2 years here in these blue areas. The low availability because of the restriction of the operational mode of the solar during the night time, and other low availabilities marked in green are because of some problem with the main electricity in the meteorological observatory of Ahtopu. And the vertical range I already mentioned that is dependent on the turbulent homogeneous availability above the solar antenna, but also from the temporal resolution, which is constant all the period. It's at 10 minutes with 20 minutes averaging, and from the operational solar updates during the years. This table presented the analysis. 3 main analyses are performed, looking for the characteristic of the coastal atmospheric boundary layer through the monthly analysis for these 3 periods. Stable boundary characteristic of the coastal atmospheric boundary layer look at the nocturnal want air masses, which occur in the time period of 22 to 05 in the morning East European time, and wind direction is from 170 to 219 degrees. And different mounts are considered. Different maximum altitude is reached for the monthly average profiles, and this is the number of profiles which are involved in this study and correspond to the this criteria for time and for the wind direction. Convective boundary layer characteristic, look at the nocturnal marine air masses when it's expected sea to be with relatively high temperature than the air above it. And convective boundary layer characteristic is observed during the daytime when air masses come from the land. And again, different mounts are considered with a different number of profiles. Here, in the third case, we're looking in the transition season when the height of that convective boundary would be in the range of the solar measurements. And all analyses are restricted up to 600 meters because of the low availability of data above this height. And one thing more, all profiles involved in the analysis with minimum 10 points in height, satisfying the conditions for time and wind direction. And interruptions are permitted only for lack of data. Here is the analysis. Let's start with the nocturnal stable boundary layer. Here we present monthly average profiles of 12 output solar parameters from left to right, from top to bottom. We start with the wind direction. This is the horizontal wind speed. This is the variance of the horizontal wind speed, and this is the vertical wind speed, variance of the vertical wind speed. East component of the horizontal wind speed is variance. North component of the wind speed is variance, eddy dissipation, and turbulent intensity and turbulent kinetic energy. The colored dots, which are on the monthly average profiles, actually present the data availability or the number actually of the profiles which are involved in the calculations of the average value at each altitude. We can see that they decrease fast in height. And for the wind speed, for the horizontal wind speed profile, we can see that it's almost linearly increase in height up to 530 meters, where 96 profiles are available for calculation of value of approximately 13 meters per second. The vertical wind speed is almost negative in height, but in 580 meters it gets positive value. The interesting thing which should be mentioned here actually is the turbulent profiles of vertical wind variance, eddy dissipation rate, and turbulent kinetic energy, where at approximately the same height, 490 and 470 meters, we have well-pronounced peak in this monthly average profiles, which is an indication for the height of that stable boundary layer of one-tier masses. And close to the ground, when we trace the change in the shape of this monthly average profiles, we can indicate other height, which is the height of the surface layer. And the different turbulence parameter shows different indications between 15 and 100 meters. On this graph, only vertical wind variance profiles are presented for the different mounts for the same case stable boundary layer of one-tier masses from March to November. Different numbers of profiles are involved for this average amount average profiles, and different altitudes observed in the shapes of the change of the shapes of that average profiles. And close to the ground again we have changes observed in this vertical wind variance profiles. Buoyancy production profile was calculated in addition from these values, and here we present three different mounts, only turbulent profiles, which vertical wind variance profile. This is the eddy dissipation rate profile, turbulent kinetic energy, and buoyancy production, which was calculated from the first one values. And this is again a stable boundary layer, air masses from land. for April, May, and July, and you can see that that peak which is observed is decreasing with sunset of the summer months, and in all turbulence profiles, the heights are almost the same altitude, and close to the ground we have indication of the surface layer in all these turbulence profiles. And here is convective boundary layer of nocturnal marine air masses presented. Again, we have vertical wind variance profiles presented for different months from May to November. And we can see that during the summer we have overability of profiles, and also the vertical range of the solar is the average profile is shorter. This is because here we talk of nocturnal marine air masses, which during the summer are not typical because of the presence of land breeze during this hot summer seasons. And again, here we present three mounts with pronounced peaks in the shape of the mount average profiles, May, June, and November, and different altitudes, which correspond or which give some indication of the height of the nocturnal coastal convective boundary there, and close to the ground here, 50 meters and somewhere 40 meters in the bouncy production, we can see that negative peaks, negative gradients is changed in the bouncy production. And this is indication for internal boundary layer height, which is formed from the marine air masses when start transforming when they start moving above the land. The last is convective boundary of land air masses, the last analysis. Here again, vertical wind variance presented. Again, typical heights of with well-pronounced peaks in these average profiles and close to the ground. Again, we see the surface layer height indication. And again, three mounts are presented with well-pronounced peaks, which are March, April, and November. And you can see that all turbulent profiles confirm very well almost the same altitudes in this analysis too. About the thermodynamic states of the atmosphere during these three cases, nocturnal coastal boundary layer, and the convective cases of marine and land air masses. The thermodynamic state is presented by diagrams of stability classes, probabilities at different altitude. So in stable boundary layer cases, during different 3 months, April, May, and June, we can see that mostly neutral and slightly stable and moderate stable here probabilities observed in different altitudes, while for the convective cases, for the marine and for the land air masses, mostly neutral and extremely moderate and slightly unstable conditions are observed. And for the future activities, plans, and conclusions, so in the future, we plan to investigate how the height of the internal boundary layer is changed according the path which is passed from the marine air masses before reaching the solar. So the marine air masses will transform more, and we will have internal boundary layer height when the path is longer. So we will investigate this in the future. And as a conclusion, we can say that the information which was obtained in this study is important for the numerical model assessment, for the dispersion model, for the climate model, for the numerical prediction model. And as well, this information can be used to determine some threshold values in different algorithms for boundary layer retrievals from other remote sensing instruments in area with similar geographical characteristics. And that's it for me. Thank you for your attention.
We're behind schedule, but we have time for a couple of questions, comments, feedback. It's been a long day, but we'll be happy to receive your questions or feedback. No questions. So since we have no questions, thank you so much for sharing your expertise with us. These were great presentations about remote sensing and the ways that we can tap into technology to address climate change and different kinds of environmental disasters and calamities or human-caused threats. Calling yours to you should have a session. It's a long day, so thank you very much.
Thank you very much. And by this, I would like to close the day. And tomorrow we will also start at 9 o'clock. And we will also deal with the sessions related to air pollution and health, and also informatics, remote sensing, and geographical info system, and high performance computing. So I wish you all the best. I wish you good evening. And I would like also to remind you that today the icebreaker will take place in the Astoria Hotel at 5:30. And now I would like also ask Dr.